Learn the 50 most popular Linux commands from Colt Steele. All these commands work on Linux, Mac OS, and any other place you have a Unix environment. Colt is an extremely popular instructor, and for good reason. He has a knack for teaching complex topics in a way that beginners can understand.
Hey everyone, my name is Colt Steele, and today we are going to learn a ton about the command line and different Linux commands. I'm a developer, well, honestly, more of a teacher who happens to write code. I teach in-person web development. I've run boot camps in San Francisco. I now do a lot of online teaching, and I have a boot camp I created with Springboard. If you want to learn more, you can find a link in the description. And this is a picture of one of my cats. I actually have to take her to the vet like in 5 minutes, really. Her tail is just drooping down for no reason. I was going to take her sooner, but, I had to make this for you. Let's hope she survives. Before I say anything else, I want to give a big thanks to Flavio Copes. I think I actually only know him as Flavio. Maybe it's pronounced Copes, but I'm pretty sure it's not. Anyway, he generously allowed me to use his Linux commands handbook. There's a link in the description, of course. Very detailed and thorough handbook. If you're not familiar with his work, he puts out handbooks and tutorials on all sorts of topics. So this is just one of many different handbooks. Anyway, he is allowing me to use his handbook along with some of the materials I've created to create this mutant super course on YouTube. So we are going to cover 50, actually I think it's a little more than 50 commands that are useful, obviously to varying degrees. Some of them you'll use every single day as a developer, for example. And then some of them you may never use except in an emergency situation once a year. But I'm going to cover a bunch of them. They're not really in a particular order, especially towards the end of the course. But at the beginning, I ended up deciding that instead of just 50 random commands in any order, I wanted to make something for anybody. So if you're a beginner, you can start at the beginning and we'll go through the basics, navigation, working with the basic commands and options and making folders and files and so on. But then after about this point, things really open up and you can jump around to whatever commands you'd like. And of course, if you're someone who already has some terminal experience, some of these commands are familiar to you, just hop around. Take a look at the description. There are timestamps and just click on whatever command you're not really comfortable with or you've never heard of. There's probably something here for you. But if you're a beginner, I definitely would recommend starting at the beginning. So aside from these commands, which there's a lot here, and this is a pretty long video, I also cover some concepts that are pretty important. So the very basics, things like why even learn this stuff? If you're not a Linux user, you're on a Mac, you're on Windows, why do you need to know Linux commands? Do you need to know them? The answer is probably yes, if you're trying to break into web development, programming, coding, engineering, any sort of techie industry. Then we'll talk about things like Unix and GNU and Linux and Unix-like and true Unix. What is all that? What is a shell? What is bash, Z shell, kernel, terminology stuff? So that's all coming up. Of course, there's timestamps if you want to skip around, if you don't care about that stuff. And then installation. So if you're on a Mac, you don't really have to do anything. If you already have Linux installed, you don't really have to do anything either. And if you're on Windows, well, we have to jump through some hoops. The good news is fewer hoops than we had to jump through a couple months or years ago. So I'm going to show you how to install something called Windows Subsystem for Linux. Then we'll also talk about concepts like command structure and arguments and options, working with man pages, folder structure of Linux, redirecting standard output, appending standard output, tilde expansion, history expansion, path name expansion, curly brace expansion, and permissions. So we're going to end with permissions. A pretty big chunk, honestly, at the end of this course is devoted to just these two commands and understanding how to read and manipulate permissions on Linux. So there's a lot here. There's some introductory conceptual stuff and terminology, installation, and then we start from the basics so you could know nothing about the terminal, never have entered a command in your life, start at the beginning and don't skip around. Or if you feel confident or you know some of this stuff, jump around, use the timestamps, they are there for you. All right, so let's start with a quick discussion around why this matters. Why should you learn these commands? Yes, at times it might seem like you're, doing stuff straight out of a 1980s hacker movie, and we're far more advanced and things have improved so much. Why do we still have to use text commands? Well, there's a bunch of reasons. including the fact that you can just do a lot more from the terminal. Using these commands we're going to learn, you'll have more control, greater access. You can do things you just cannot do otherwise. There's just no way around that. If you want to start a server, manage different processes, interact with databases, all sorts of things, alter permissions, you need to know terminal commands to do that. Another reason, it's faster. At least once you get past the basic hurdles, you learn the commands, you get used to them, you can do things way faster. We can make 10,000 files in a single line. I can make 10,000 empty files, all with different names. Doing that graphically with my mouse or file new, save, file new, save would take hours. Now that's just a sort of far-fetched example, but in general, we can do things much faster. The one problem is that when you're learning, it's going to be much slower. I kind of already hinted at this one, but we can actually automate things. We can speed up repetitive processes. We can save ourselves a lot of time. Another reason, it's available everywhere. So if you learn these commands, you'll be able to work on any Linux distribution. You'll be able to then switch over to a Mac if needed and use the commands on a Mac. Now on Windows, yes, it's a little bit different, so it's not technically available everywhere, but these commands we're going to learn are pretty standard across any sort of developer, software engineer career. Which leads me to the next point. It's essentially a requirement. If you want to be a web developer, data scientist, DevOps engineer, sysadmin, security admin, machine learning engineer, AI engineer, whatever, any type of coding related career, you are probably going to need to use the command line. You will have tools that only exist on the command line that you'll need to be able to use. So for a lot of people, that's the only reason that really matters. You just need it if you want to get a job. It's just part of the expected skill set. Also, a lot of cloud computing programs or services don't even have a graphical user interface. You just have to do things via a command line. And again, high-paying jobs, lots of careers, lots of roles that you'll need to at least know the basics of working with terminal commands. So the next topic I'd like to quickly discuss is a little bit of context around operating systems and why these commands will work on Linux and on Mac by default, but they're not going to work on a Windows machine, at least not out of the box. So there's quite a lot of complicated history and drama around different operating systems, things being open source versus closed source, and competition and copying each other. It's quite dramatic, but the general gist that you need to understand is that over the years, since the very early days of computing, well, maybe not the super earliest days, but we're going back to the 70s here. This is a timeline that shows a very detailed timeline that shows operating systems and how they're connected. Anyway, in the 1970s, there was something called Unix. You can see it here. And just take a look at all of these lines, this whole family of operating systems that it spawned. So there's lots and lots of them. Everything in red here is considered in some way related or indebted to Unix. So that includes things like Linux. So in this course, I'll be using Ubuntu, which you can see here. It is a distribution of Linux, but there's many, many others. Things like Android, Chrome OS, but also other more common Linux distributions like Fedora or Red Hat. Anyway, all of this Linux stuff is descendant from Unix all the way back here in the 70s. Now we also will see somewhere in here all the different Mac operating systems. Here we are. So Mac OS X, we've got iOS, the Apple TV OS, Audio OS, Watch OS, all these different Apple products, all the Apple operating systems, also related to Unix. But then our good friend Windows, somewhere down here, it's not even in the same red color, just to show how it is completely different. It is in green. This world of Windows, so Windows, Windows Vista, Windows XP, Windows Mobile, Windows Phone, Xbox OS, all that stuff is over here. It's just kind of on its own. It is not related. It is not, a descendant of that original Unix operating system from way back in the 70s. Now, the reason this matters is that all of these guys in red up here, they tend to share the same commands. Unix was this operating system developed in the mid-60s at Bell Labs, really cool time, lots of innovation going on. But what matters to us today, 50 plus years later, is that lots of those innovations, lots of those new ideas and the specific commands, the actual interfaces, the way a file system was structured, all of that carries over today. Yes, it's changed, it's been expanded, but it is present in all of those red descendants of Unix. Unfortunately, for our Windows users, those commands don't exist natively on Windows. Windows has its own set of commands, its own default shell, its own way of doing things. So I'm going to talk about how we can get these Unix commands to work on Windows, but just so you understand why this is a problem in the first place, it just has to do with the history. There are so many of these OSs over the years inspired by and descended from the original Unix OS, including Linux and Mac OS, but not Windows. Lonely Windows over here. All right, so now we have a basic understanding of the fact that of today's operating systems, there's really those two groups. Everything descended from Microsoft, and then kind of everything else that is in some form, some way related to Unix. Now that's a vast simplification, but again, we're just talking about popular operating systems. So, Linux, Chrome, Mac OS, all these things come from Unix. Now, let's talk about Linux and Unix and all that stuff in a little bit more detail so that you understand what exactly Linux is, why it exists. So this is a diagram. It's from Wikipedia that shows the history going back to 1969, early Unix versions, and how it spawned all the other operating systems that are connected to it. Now, what you'll see is that there are three colors. Red is closed source, or pink, and that means the code is completely closed off. You can't edit it, you can't view it, you're not allowed to even try to tweak it. Then we have open source, which you may be familiar with that term. The code is openly viewable. You can change it, tweak it, make your own versions, try things out. And then there's, in yellow, this mixed/shared source type of operating systems. So what you'll see here is that early on, Unix and a lot of other operating systems in the early days were mixed or shared source. But then there was a plethora of closed source operating systems that were very walled off, and you were not allowed to do anything with that code. You were not allowed to view, edit, tweak, and so on. And that led to the rise of something called the free software movement. Free in this context does not mean no money, free beer. It instead means free in the context of freedom, free speech. So this software movement was all about the idea that you should be able to collaborate. You should be able to edit code, view source code, run, copy, distribute, study, change, and improve software. It should not be walled off. And the leader of this movement was this guy named Richard Stallman. So he began work on something that ended up being called GNU, G-N-U, that was his own free software alternative to Unix. So he wanted to make a full operating system that had everything that normally came with Unix, but it was going to be completely free. Again, free meaning you could tweak it and edit it, do whatever you want to it, and see the source code. Now that's a huge undertaking, creating an operating system. And at the same time, this other developer named Linus Torvalds, or Linus Torvalds, was working on something called a kernel. And we'll talk about what that is in a moment. But this kernel he was working on, he called it Linux, and a kernel is a very complicated and critical part of an operating system. It is the thing that basically sits between the hardware and the software, and it facilitates the interactions between different pieces of software and then the physical hardware of the computer. So what happened is that Richard Stallman was working on the GNU project, trying to build a full operating system. Well, he didn't have a kernel. But at the same time, Linus Torvalds was working on a kernel, and Torvalds ended up merging his kernel with the existing GNU components from Richard Stallman to create this whole operating system. Just a quick note, so I don't get any negative comments here, there is a bit of controversy over the name of the resulting operating system. A lot of people, most people, have heard of Linux. Fewer people have heard of GNU. The term Linux, often people use it to refer to the entire resulting system, when in reality, the Linux kernel was just one piece that was added on to some existing components. But what matters for us here, if we go way back to this slide over here, is that what we see is a bunch of closed source, mixed source operating systems all over here. And then this thing called Linux pops up right there around 1991 in green. It's open source. Now, there's not a direct line, as you can see, going back to any of these what are called true Unix operating systems. And the reason for that is yet another piece of history. There is a global consortium called the Open Group. They own the trademark for Unix. In order for you to call your operating system Unix, if you make an OS and you want it to be certified, you have to pay a lot of money, you have to go through a bunch of testing, you have to comply with a bunch of regulations and standards, and it's a complicated process, and there's money involved. It's not very free software. So, we have another term. There's true Unix. You've been certified as a true Unix operating system. And then we have Unix-like operating systems, which are compatible with the Unix standards. They implement things correctly, but they haven't been certified as actually true Unix. And this is often because of financial considerations or ethical objections to the existence of the idea of true Unix. So what we see on this slide here is Linux enters the picture. It is not considered true Unix, but rather it's considered Unix-like. Remember that Linux itself is just a kernel, which is very, very important. It's, again, that piece of the operating system that connects the hardware to the software. So that's what Linux is really. It's the kernel. But when we talk about things like Ubuntu, what Ubuntu is a Linux distribution. It is one of many, many distributions out there. There's nearly 1,000 last time I checked. You may have heard of Fedora, Slackware, Ubuntu, that's what I'll be using. And what each distribution is, it's the Linux kernel. It's some GNU tools, documentation, a package manager, a desktop environment, a window management system, a whole bunch of other things combined together to form a full operating system. So to recap all of that, there are tons and tons of operating systems on this chart. You can see some are open source, some are closed source, some are mixed source. Some of them are considered true Unix. They've been certified by this foundation or this consortium to be true Unix. But then over here we have Linux. Linux is fully open source, and whether you call it Linux or Linux GNU or GNU Linux, it is a Unix-like operating system that conforms to all these standards that these operating systems do. We can use the same commands. Things are structured the same way. There are subtle differences, but it doesn't really matter. Everything on this chart here, they're all part of this greater Unix family or Unix-inspired family. Now we have one last piece of terminology and history and all that stuff to get out of the way before we move on to actually running commands. We need to talk about the term shell. So you may have heard of this before. If you're on Windows, you may have heard of PowerShell, or you may have heard of Bash or Z Shell, or you maybe never have heard of them. But there's this concept of something called a shell. What the shell is a very, very important piece of software that is going to expose the operating system itself to human users or to other programs. So it is the thing that takes our commands and hands them over to the operating system to actually perform. And the term shell comes from the fact that it's the outer layer around the operating system, like the shell around an oyster. So there's this other term, terminal. Way back in the day, a terminal used to be an actual piece of hardware. It would have a screen, and it was a physical device with a keyboard. You would go over and you'd enter your commands into the terminal. Today, terminal is just a piece of software. It's an application. There's many different terminal applications. It's the place we go to type our commands. When we hit enter, there's some shell that we are using in that terminal window. By default on Ubuntu and most Linux distributions, that shell is called Bash. On Macs these days, the shell is called Z Shell, ZSH. Another very popular shell is Fish. There are many other shells out there though. And again, their job is to take commands that we provide or other applications, humans or applications provide, and then give them over to the operating system and make sense of it all. So again, I'll be using Bash. That's the default shell that comes with Ubuntu. But if you're on a Mac, I'll talk about installation, and you'll see that fortunately, Z Shell is very, very similar, and the commands are still going to work. So it's not a big deal at all, but it's good to know that there are different shells. And then the job of that shell is to take those commands and pass them over to the operating system. And as I mentioned, Bash is the most popular shell out there, especially on Linux-based systems. It is the most common default shell. And the name, if you're wondering, it comes from Born Again Shell. And it really doesn't matter, but it's this reference to this guy, Stephen Bourne, who created a different shell called SH, a direct ancestor of Bash. So there's SH and then Born Again SH. And again, Bash will run on pretty much every version of Unix or Unix-like systems. So it does run on Macs. It runs on, any Linux distribution, any of the Unix operating systems that you can see on that massive chart. Next up, let's talk about setup and installing things if needed so that you can run these commands. So right now we're looking at a Linux distribution. This is Ubuntu. This is the Linux distribution I'll be using throughout the course. If you already have Linux, if you have some version of it, some distribution, just use that. It's going to be very, very similar. All that you need to know is there's a built-in terminal application. If I just search for terminal, I'm going to be running my commands in here, probably change the color, and this is where I'll type my commands. So if you are on a Mac, you do not need to go and install Ubuntu in a virtual machine. That's actually how I'm running this. I'm still on my Mac here, but I'm running it in a virtual machine. You can do that, but unless you have a really good reason to, I would just stick with what you know, because the commands that I'm going to show you will work on a Mac. All right, so this is just for users who already have Ubuntu. Here's the terminal app. You just search for it, and we'll run our commands there. Now, if you are a Mac user, remember it's part of this Unix family, Unix-like operating systems. All the commands I'm going to show you will work on the Mac. All you need to do is search for terminal, and it will probably look a bit different than this, but you will have a terminal where you can run the same commands I show you. So over here on Ubuntu, when I show the psaxww command, it works. You don't need to run this, by the way. But over here on my Mac, same thing, psaxww. It also works, and it we'll actually learn what this is, but it gives me a bunch of stuff. All right, Windows users, it's your turn. Let's talk about installation and the steps we need to go through in order to run Linux. So remember, the problem here is that on Windows, we just don't have access to the same commands. They're implemented differently. Windows is not part of this Unix family, this Unix-like family of operating systems. So this means that a lot of the commands you'll learn in this video and that developers use every single day are not going to work on Windows, or they'll work differently, or they'll partially work. Now, Windows has its own set of commands, and you could live in that world exclusively. It's just a different world. So if you want to use a lot of the common developer tools, and you're watching this video, you probably already know what you want to do, we need to get some way of running Linux commands on Windows. And the way that we do this is really two options. There used to only be one. We used to have a virtual machine. It's a pain to install. It's totally isolated from your actual Windows operating system, and it can be slow, can have a lot of overhead. Now, instead, we have a really cool fancy option called WSL, Windows Subsystem for Linux. This is actually put out by Microsoft, and it allows us to run a Linux environment directly on Windows or inside of Windows. So it's not isolated, it's not a virtual machine. It actually works directly inside of Windows. It's just a command line version of Linux, to be clear. So we're not going to have a separate desktop. You're not going to have all the apps and stuff that I have on Ubuntu. But that's kind of the point. You can still be a Windows user and have Linux commands from the command line. So it's really, really cool. It's updated pretty frequently. It's still under active development. And the really good news is that it's a lot easier to install these days than it used to be. You do need to make sure you have Windows 10 version 2004 with build number 19041 or higher, or Windows 11 in order to use the simplified installation instructions. Otherwise, you can follow. I would recommend going to this webpage anyway, docs.microsoft.com, look for WSL, because this does change. But if you have an older version, you can still install WSL, you just have different instructions. But if you have the appropriate build number or higher, all we need to do is from the app called PowerShell, which I have open right now. You can just search PowerShell. Okay. This opens up this terminal where you can see PS, by the way, I'm using PowerShell. I can type commands in here and it tells me, in that case, I don't know what the heck you're talking about. But the command we want to run is WSL-install. So let's try it. WSL-install. The requested operation requires elevation. So what this is telling me is that I need to have admin privileges or permissions to do that. So why is that happening? Well, I need to run PowerShell as an administrator. So I'm going to search again for PowerShell, but I'm going to click on Run as Administrator here. All right, and that opens me up a new window. It says Administrator, Windows PowerShell, and we try again. WSL-install. Whoops. and it might take a little while. So I'll be back when hopefully this finishes successfully. And if not, I guess he'll watch me debug it. Oh, check it out. Already we can see it's downloading Ubuntu. So that's the default Linux distribution it uses. When I first installed WSL a year or two ago for a different course, you actually had to go and download your Linux distribution separately. You had to go download WSL separately. You had to then connect the two and point it to the particular installation, and it was just a huge pain. But now, hopefully, super easy. Take a look. It says the requested operation is successful. That's always good. Changes won't be effective until the system is rebooted. So let's reboot. Okay, so once that finishes up, I restarted. I now have, actually when I restarted, it automatically opened up Ubuntu, which is now installed. It wasn't even a thing before. Now I have an app I can run called Ubuntu. It opens up right now, at least this terminal that I can see here, and it tells me, I had to install for a few minutes, and then it wants me to set up a default user account. And this username that I set up does not have to match my Windows username. But whatever you do, you want to remember what you put in here. So this is going to be for our Ubuntu part of this machine. I'm going to make my username Colt and then a password. And you'll want to remember that password. You're not going to see what you're typing, but I'll hit enter and then retype it again. You can change that password later. I'll actually show you a command you can use to change that password. And there we are. I now have Linux. I'm running Ubuntu on my Windows machine. So the commands will learn things like pwd and who am I, just to show a couple simple ones, or psaxww. There are lots and lots of commands we're going to cover, and they now will work. These commands are running on Windows. Now, there is some additional setup you can go through. If you go to the installation documentation, they recommend on Windows that you, whoops, this is the wrong page here. They recommend that after you set up your Linux user info, which we just did, that you can also install an app called Windows Terminal. And Windows Terminal is, remember, a terminal is just an application that can run different shells, and it can sort of be a jack of all trades. We can use Windows Terminal as our terminal. It's just a more sort of fancy, better features, more customizable terminal application. So you do not need to do this. But if you want to, you can install the Windows Terminal app. And you can make it look all nice and pretty and run Ubuntu from inside Windows Terminal rather than the default terminal that comes with Ubuntu. So one more time, perfectly serviceable just to use this terminal. But if you want to get Windows Terminal, if you're serious about, mastering all this stuff and working as a developer or some other, you want to use a terminal day in and day out, Windows Terminal is just the better option. It has more features. So I'm going to install it. I'm going to download it just from Windows website or Microsoft's website. And now that it's finished, I'll click Launch. And remember, a terminal is just like a piece of software that can connect or interact with different shells. So right now it opened up with PowerShell, which is not what we want to use in this course. First of all, let's see if I can just make this larger font for you. There we go. Okay, it's a little bit larger now. So as you can see, it's using PowerShell. But I can click this little drop-down arrow here and switch over to instead use Ubuntu. So now I'm in Ubuntu. You can see my prompt changes here. It has my username in there. You can customize the appearance and all of that. So if we go to settings, you can go down to Ubuntu. You can set up a different appearance, font size. But what you can also do is set the default profile to be Ubuntu. And if we save that, it now means when I make a new window, if I just do plus, it is Ubuntu. You can see my little Linux penguin. That's the logo there. And we're now up and running with Windows Terminal. There's a lot you can do to customize it, but that's not really the point of this course. So now you have it. Run your commands here. When you see me run them in Ubuntu, run them here. Okie dokie. That should hopefully wrap up installation. Whether you are actually running Linux like I am right now, Ubuntu, this is the desktop version. I have the terminal open. I will be running my commands right here. But if you're not, maybe you're using a Mac. So here's my Mac. I've got my terminal open right here. I'll run commands inside the terminal application here. They'll work just the same. And then finally, if you're on Windows, hopefully you installed WSL. So here we are. I'm running, this is Windows Terminal. I make sure I'm running Ubuntu here. I run my commands right here. So whichever one you're on, just make sure you know where you're going to be running those commands. If you're on Windows, make sure it's not PowerShell, because you'll run into problems. We want to make sure we are running Ubuntu so that our Unix commands will work. Otherwise, they won't. Yes, by the way, all three of these are on one computer right now. I've got Linux, Windows, and my Mac. Okay, let's get started. Okay, so now that we hopefully have everything installed correctly, we can go ahead and get started. Now, before we do, the first thing I just want to make clear is that for the most part, there's no order to the commands in this video. It's a bunch of commands and they're useful, and most of them don't really have to do with one another or depend on each other. But early on, right now, I'm going to go through some of the very basic commands, and there is a logical order to how I'm going to teach them. All of that is to say, if you're a complete beginner, stay right here, and we'll go through the basics in order. But if you have experience, if you know the basics of ls and man and cd and pwd, you may want to skip ahead. So check out the timestamps in the description below, and click on whatever command looks interesting or you'd like to learn more about. But if you are new, stick with me. Let's go ahead and get started. All right, so before we talk about commands, let's talk about not commands. In my prompt, if I start typing really anything and I hit enter, the shell is going to try and process that and figure out what command I'm referring to. But I'm not referring to any valid command, so I get a message that says command not found. Same thing on a Mac. Type gibberish, we get command not found. And same thing over here on my Windows machine, although I'm running Linux on Windows. And I get command not found. Okay, hopefully not that surprising. So what we want to do is type commands that actually make sense, that the computer can figure out what we're referring to, and then run some corresponding program for us. And the first really simple one I'm going to show you is maybe not that useful, but it's just a good demonstration of a simple command. It is who am I? All one word, no spaces. Who am I? All lowercase. It's going to print the username of the currently logged in user. So maybe not something you need to do all the time. You probably know who you're logged in as, though there are uses for this, especially in scripting, if you write scripts later on. But anyway, if I just run it here, who am I? Over here on my Ubuntu installation, I am logged in as Colt. That is the username I have. Here's my Mac. If I run who am I, my username is slightly different. It's my full name, Colt Steele. And I think on Windows, it's just Colt as well. All right, so that's our first official command. Really, really simple, hopefully. Nice and straightforward, right? There's a difference between just typing gibberish and typing a command that is recognized. But it is important to note, who am I, like this, is not the same thing at all. There's no real autocomplete or spell check or anything like that. The terminal is just going to take what you give it and try and find that program. So it can't find this program. Who am? It only knows who am I. Okay, so the next command we'll look at is called man. The man command, M-A-N, is short for manual. And that's exactly what it is. It is a command that it doesn't do anything to our system. It's purely informative. It tells us information or manual pages for commands, as well as some other things, not just commands, but we're going to focus on the command side of things. So anytime we have some new command, like we just learned, who am I, we can actually run man followed by that command name to get a manual page entry for that command. So if we need to learn more about who am I or any other command, most likely you won't need to learn more about who am I because it's so simple, but we can do just that. We can run man followed by a command like who am I? Hit enter. And our screen changes pretty drastically. That prompt goes away. I can't type commands anymore. What we see here is a man page. It tells us the name of the command, prints the effective user ID, something called a synopsis. We'll come back to this when we learn some other commands, and then a description. Print the username associated with the current effective user ID. Pretty straightforward. There's not a whole lot here. We can see who wrote the command, and we can find a place to report bugs. This is a very simple man page. Some commands have very long pages, dozens and dozens of pages you would actually need to scroll through. Now, important to note, first of all, to get out of here, we need to type the letter Q. If you forget that, you can find it down here. But remember, I am not at my prompt right now. I can't type commands. So I can't type, who am I? If I type things, I start to see a whole bunch of other text appear. I'm actually looking at some help that tells me more about how this program works. So it tells me, you can exit by typing Q or uppercase Q or ZZ. You can type H to display the help page that I'm looking at right now. So that's what happened. I typed who am I, hit H. But anyway, I'm going to type Q to get out of there. Now I'm back to the man page for who am I, and I'll type Q again. So just one more time. If I type man, followed by some command, if I want to get out of here, type Q. And now I can type commands again. So if I try and run man on its own, it's going to tell me, what manual page do you want? This is a manual command. I need to know what you want a manual for. So we can actually do man. And that gives us the man page for the man command. It's an interface to the system reference manuals. There's a bunch here. One thing I'll just point out quickly is that we can scroll by using the mouse. That is one option. But it's a lot easier to scroll one page at a time by hitting space. There's a lot of text here, and I can scroll down by hitting space rather than having to. I can also use the arrow keys, by the way, to go one line at a time, up and down, which is what I'm doing right now. Space to go down a page at a time. Q to get out of here. All right. So that's the man command. Nice and simple, hopefully. Very useful, especially when we have more complicated commands. The next command is also nice and straightforward. It is called clear, C-L-E-A-R. And this command will clear your terminal screen. It is useful, although I'll also show you a shortcut that you can use in place that's actually much shorter. So CLEAR will clear the mess on your screen if you have a bunch of stuff here, like I do. CLEAR, enter, and it's gone. So I'll just show another example of that over here. This is on my Mac. Let's do some more commands. How about man clear? Let's just take a look at that. Here is the manual page for the clear command. It clears the terminal screen. So I'm going to hit Q to get out of here. So I have a bunch more stuff. Let's just pretend that's all valid commands. I want to get rid of it. Clear. All right, nice and easy. Now let's take a look again at the man page for clear. This is on Ubuntu. And I want to talk about this right here, the synopsis. So we see the name, it's clear. Here's a little description. It clears the terminal screen, nice and easy. Now, the synopsis is actually showing us the syntax, the accepted options and values we can pass to the clear command. So clear is a command that accepts an option. We can see, if you see anything in square brackets here, it means it's optional. So you can pass this in, you can pass this, uppercase V, lowercase x. Now, what does that mean? Well, commands accept options that alter their behavior. You can change how a command functions. So if we scroll further down, we can see under options a description of what these different options do. Now, the one I want to talk about is -x. Now, I don't use this frequently, but it's just a good intro to options here. It says that it does not attempt to clear the terminal's scrollback buffer. Using the extended E3 capability, I have no idea what that part means. But what this means overall is that when we clear with the -x option, it is not going to clear our scroll history. So I'm going to get out of here and demonstrate this. So I'm going to hit Q, and let's make some history in here. Hello there, I love you. Okay, none of those are valid commands. I can scroll back and see those commands. And if I type regular clear, it's gone. I can't scroll back. That history is gone. Now, if I recreate some of that, hello there, I love you a lot. If I use clear, but this time I provide -x, and that's our first example of an option. There will be tons of commands we see that accept options, and they can drastically change the behavior of a command. I'm going to hit enter, and it clears, but I can scroll. So I don't use that often, honestly. I'm not showing it to you because it's something you need to know. I'm showing it to you because it's an intro to options. Now, one more thing. I mentioned there's a shortcut, and I don't really type the clear command anyway. The shortcut is Control-L. So if I have a bunch of stuff again, I want to get rid of it, Control-L, and it's gone. So that's definitely easier than typing clear. It also works over here on my Mac. It works on WSL, just Control-L. Okay. So that's a clear command, nice and easy. The next command is also nice and easy. It is PWD. It stands for Print Working Directory. And this is a command that just tells us our current location in a given terminal window. So let's start with man, pwd, and it tells us pwd prints the name of your current/working directory. So just like when we have, I'll open up my file explorer here with my graphical user interface using my mouse. I have a current directory that I'm inside of. I'm viewing right now my desktop, as you can see it selected there, or I can view documents, or I can view my home folder. This would be my current working directory, home, in this window right here. But in a terminal, it's a little bit different. Let me get out of this man page here, hit Q. If I type pwd, it tells me in text where my location is. So in this window, I am on the desktop, which is located in the cult folder inside of /home. Over here, this is a different terminal window. It has a different location. Just like I can have multiple file picker windows. Here's another one. This one's in my home directory and this one's in desktop. Same idea. So I can have, in this case, pwd, a terminal window that is in /home/cult/bin. And here's one more different window, a much longer path. This is the full path to get to my location. Now, I haven't shown you how to move, so you probably don't have something like this set up with these different windows. By default, you can actually configure the default location of a new terminal window. For me, when I make a new terminal window, I'll just click that button there. You can also use a shortcut. It defaults to the desktop, at least on Ubuntu. Over here on my Mac, when I make a new window, it defaults to what is called my home directory, /users/my username. You can configure all of this, but it doesn't really matter where you are at the moment. All that matters is that you can find it by typing pwd. All right, so the next command we're going to cover is called ls. The ls command is short for list, and we use it to do just that. It will list the contents of a folder, so we can see what is inside of a directory. Normally, if you're using a graphical user interface, you don't need a command. You just can see the contents of a folder. But in a terminal window, that is not how things work at all. We have to ask for a list of the contents. So here I'm on my desktop. As we can see, I ran pwd. It says /desktop. You can also see my prompt is displaying desktop there as well. That is also something you can configure. By default, though, on Ubuntu, it does show you your current location. Anyway, if I actually look at my desktop, I can see a bunch of stuff there, and I can list it out using the ls command. So if I run ls with nothing else, just ls, it's going to list the contents of whatever current directory I'm inside of. In this window, it's the desktop. And here we go. We get a bunch of text. So we see things like, my folders. Some of them are quite odd here. I've got wildlife. I've got files like greatgatsby.txt. So there's some different colors, and folders for me are bolded. Files are not bolded and they're just showing up white, but that's all configurable as well. But this is showing me all the contents of my desktop. If I try it somewhere else, here I'm in this /bin directory. I'll type ls. I see different contents. Here, that's my desktop. All right, well, let's try it on my Mac here. This is my home directory. I see a bunch of other stuff, right? This is different. I see folders for my courses I make, my desktop, my documents, labs, some random things that I need to get rid of, like hello.js and orange.python. Those are my files and folders. Now, we also can provide a folder that we want to look inside of. We can provide a path to ls. So instead of just looking at our current location, I could peek somewhere else. So for example, right here, let's see, I'm on my desktop, and we saw that there is a wildlife folder on my desktop. I could ask what is inside of there by running ls wildlife, and I can tab complete, so I don't have to type the whole thing, and hit enter. And I have no idea why I have a wildlife folder that contains 3 text files called Angela, Juan, and Nico survey. Doesn't sound like wildlife to me, but okay. I've got a meal diary folder. Let's take a look in there. And it has nested folders inside. So now we can even burrow further in if we wanted to. From my current location on the desktop, I could look inside of meal diary and look inside of Friday by doing this. ls meal diary /fry. And I'm using tab complete. So I'm giving it a path that is beyond. It's not just one folder name, it's now 2. that I want it to peek inside of. So peek inside of this. And we have breakfast, dinner, and lunch. So I can actually run this again and let's see what's inside of breakfast. I don't know if there's anything in there. I'm going to recall the previous line by hitting the up arrow and then just add a B and hit tab. Yeah, there's nothing in there. No, it's a bit of a letdown. So that's one example of using ls where we provide a file, or rather a folder path, but we can provide a full, what's called an absolute path to any location on our machine. So this file, breakfast, or this folder, is inside of Friday, is inside of Meal Diary, which is nested in the desktop, which is where I currently am, right? PWD, I'm on the desktop. But maybe I want to see what's inside of my Documents folder, and Documents is not on my desktop. Well, one option is to do this, ls, and then the full path to my Documents, which is /home/Colt/ I think it's uppercase, Documents. So I'm using tab completion again, so I don't type that myself. I don't know if there's much in there. Nope, just a single file, but we can see kenneth.txt. Now, I could get there, right, by just opening the file picker, going to Documents. Yes, I see it. But there are some special things that we can do with the ls command in the terminal as well. But just to recap what I showed there, we can provide what's called a relative path. So relative to our current location, I could just say, show me, list the contents of Meal Diary. But that only works if I'm on the desktop. If I'm somewhere else, I can't just reference Meal Diary. I need to reference the full path. And that's exactly what I did down here to get to Documents. The Documents folder is not in my desktop, so I can't do ls Documents. It's going to tell me I don't know what you're talking about, that doesn't exist here on the desktop. But if I provide the full path, this is the unique location, the absolute location of Documents. I can see, it's not exciting, but I can see there's one file. All right, so now let's talk about some of the options ls accepts. So let's use that clear command or use Control L. And then let's run man ls. It tells us it does list directory contents. And then it says that there's a bunch of different options. And I'm going to scroll through them. These are all the options. A lot of them. Most of them I don't use. That doesn't mean they're not useful. There's a lot. I want to highlight two that are very useful. The first one is -L. So let's find it here. -L, come on. HIJKL. Doesn't tell us much, but it says it will use a long listing format. So this means I can take a look around with ls, and rather than just getting the file or folder name, I can instead add -L and get a whole bunch of other information. So there's a lot we're not going to go over here, but there's file permissions, there's the owner of the file, there's the group owner, there's file size information, modification date, the file name. So a lot of stuff here for each individual file. So that is -L. Now another thing we'll take a look at, another option, I'm going to go back to man ls, is -A. Now -A, you can also do the longer form --all. All it says is that it does not ignore entries starting with a dot. When I just type ls, I don't see any files or folders that start with a dot. ls-a, I now see quite a few. .bash, a bunch of stuff. .profile, .less something, .sudo something. There's probably some different ones on your machine. I'll just try another example here, ls-a. On my Mac, lots and lots of files that start with dot. They don't show up if I do a regular ls, which you can see right there. Nothing starts with a dot. Now we can combine options as well. So if I want to, clear the screen, I can do ls-a to see all files, including ones that are hidden. -L, I want the long format. That is one way of doing it, but the much shorter and more common way is actually just using a single dash and put your options together. So -al or -la, I see the long format, all the information for regular files and files and folders that start with a dot. So we're getting both of those options taking effect at the same time. So that's an intro to the ls command. So we've seen how to find our current working directory, where we are, and list the contents of that directory. Now, how do we move around? How do we do the equivalent of what I'm doing right here in the File Explorer, double-clicking on, the desktop and then going into this folder, or going back? how do I move around like I am right here? Well, in the terminal, the way that we do that is by using the cd command. CD is short for change directory. Now, the first thing you'll notice if you try and read the man page for CD, it does not exist. It just isn't there. When I try it on my Mac, I see something, but it is not a man page for CD. If we look up here, it's a man page for a bunch of commands, tons and tons of commands, including CD. Well, what's going on here is that the cd command is actually implemented by the shell. We don't need to dive into the specifics of really at all. Just I want you to know that you're not going to find a super helpful man page for cd. It's one of the few commands that we'll cover that does not have a man page. However, you can run help. It's a different command. It's like the shell's version of man, help space cd. And it's kind of annoying. It just prints out text. You don't enter that program where you can scroll nicely. It just takes up a whole bunch of text, but it does tell us it changes the shell working directory. Change the current directory. There are some options. We're not really going to use those, however. Let's just see how it works. So I'm going to clear my screen first of all, remind you where I am. In this window, I am in my home/Colt folder. If I type ls, I see a bunch of other folders. So let's say I want to move into one of those folders. How about my desktop? Well, the way that I do that is by writing cd and then specifying that path. So I'm just going to do de tab. Hit enter, and you'll see my prompt changes. If I type pwd, you can see my location has changed to be home/Colt/desktop. Before, it was just home/Colt. So I just double clicked into that folder, but I didn't click anything. It was all done via the terminal. So I type ls, I'm on the desktop now. Let's go into the meal diary folder, cd into meal diary. All right, and we're now in here. I can cd into about Friday. Type ls or pwd, you can see I'm now at this pretty long path. If I type ls, let's cd into breakfast. So that's a really common thing, ls and then immediately after cd. You use ls to look around and then cd to change directories into something that you just found. So now I'm in this folder breakfast and I've hit a dead end. There's no more folders to cd into. How would I back out? Right? Normally, if I did the exact same thing, so on my desktop with the graphical user interface, it was meal diary. Is that right? If I can find that, I double click, Friday, breakfast. Okay, how do I go somewhere else? Well, I have a bunch of options. I can hit the back button. I can use these buttons up top to jump around. But here, how do I go back with the cd command? Well, the answer is to use cd followed by ... So 2 dots is a special path that indicates or it refers to the parent directory. So it's how I can back up one folder. Right now, I'm in breakfast. If I cd ... now I've gone back one level into Friday. pwd, you can see I'm in Friday, type ls. This is the contents of the Friday directory. So that's how I can go back one level. I can go back further and repeat it. And now I'm back on my desktop. Now I can also, instead of just CDing into one folder at a time, one level at a time, I can jump to any location on my machine as long as I have the full correct path. So if I wanted to go back to where we just were, which was this location here, right? Desktop, meal diary, Friday/breakfast. I could do that in one step, cd, and then meal diary/Friday, I'm using tab/breakfast. So I don't have to do 3 separate CDs. I can jump as many levels as I want. And the same actually goes for moving backwards. I don't have to do cd ... enter, cd ... enter. If I want to move back multiple levels, I can chain it together. I can do this. This is one option. So it's a little clunky to do it this way, but it does work. So this is going to take me back one parent folder, and then its parent folder, and its parent folder. And now I type pwd, I'm back on the desktop. I can also pass an absolute path to cd. So everything we've done has been relative to our current location. But if I want to go to my documents folder, well, it's not here. It's not in the desktop. I can't do cd documents. If I try, it doesn't know what documents folder I'm talking about. It's only looking in my current location, and there's nothing called documents on the desktop. My documents folder is located at this path. It is /home/Colt/documents. And I can jump right there. It doesn't matter where I am. I can run that command anywhere. And I'll be able to get to documents. I'm now in documents. One other note around CD and path names, you'll see this tilde. That refers, it's a shorthand that is eventually expanded into your home directory. Now, it's kind of confusing because this is called home, but the home directory for each user is a directory with their username. So for me, it's Colt. So if I cd to tilde and I do pwd, it takes me to /home/Colt. If you cd to tilde, it will take you to whatever your username's folder is. And this folder is a very important place. It has the desktop, it has documents, downloads, a whole bunch of stuff. You can put your own things in here too, but even just if you do nothing, it contains a lot of important folders and documents. So that's kind of the basics of CD. You can CD into a location that's relative to where you are, like desktop. I can do multiple levels at once. I can back out with cd ... We combine it often with ls. Take a look around. Where do I want to go? Let's go into wildlife. CD, wildlife. Okay, I got some stuff in here, and I'm not going to do anything with it. Let's back out. And I can also pass an absolute path at any point, which is, again, a full path name, not relative to our current location. So that is the cd command. So next up, I want to talk a little bit more about folder structure and how things are organized. If you noticed, when I talked about absolute paths, all absolute paths started with a /. And the reason for this is that the very, very highest level directory on our machine is the / directory, also known as the root directory, which is really confusing. People call this root, but there's also a directory called root, ROOT. Definitely confusing. In the same way that people refer to, my home directory, Colt, if that's my username, that would be Colt's home directory, but there's also a directory called home. It's not the most straightforward thing. So the top level directory is /. We can actually go there if we wanted to. From anywhere on my machine, I can do cd /. And if I take a look around, we've got a bunch of stuff that we normally don't mess with, at least not as a typical day-to-day user. If you start writing scripts, if you start doing admin stuff, absolutely, there are changes you can make here. But we can look around. There's a bunch of different files or folders and things called symlinks that we'll learn more about later on in this video. And that's kind of all I'm going to show in this directory because there's just so much here. But what I want to mention is that your desktop, your documents, your music, your whatever files and folders you make typically are going to live inside of the home directory, inside of your particular username. So for me, my username is Colt. We can always find that out if I need to. It's also just right here in my prompt, Colt. So I can go into the home directory. I'll cd into that. If I take a look around, every user on my machine has their own unique home folder. So Carrot, Colt, Elvis, and Kitty. Let's take a look at Kitty's directory. Whoops, not Kits. Kitty. And you can see we've got desktop, download, documents, pictures, and all the stuff that we would expect. I'll back out again, and then I'll go into Colt. And this is where we've been working. Now, I just wanted to reiterate how this all works. / is the root. It's the top level directory on our machine. We cannot go higher than that. If I try and go to / and then back out, I'm not going anywhere. I'm just staying right there at /. Now, as I said, every absolute path starts with a / because an absolute path is the full location, the unique full location to reference a particular file or folder. So it always starts with a /. Now, another character that we've talked about briefly is the tilde here, which refers to your individual home directory. So if I cd to tilde, I'm logged in as Colt. That will take me to /home/Colt, as you can see right here. Okay. And that's all I really wanted to mention around folder structure. Of course, there's a lot more. There's all these folders. There's dozens of folders here that we're not going to discuss. Everything we're doing lives inside of our particular username home folder. So /home/Lily/home/Colt. And then remember this difference between relative and absolute paths. If I wanted to go, let's see, where am I right now? I am in my home directory. If I want to go onto my desktop, from here I can just cd into desktop. That is relative to my current location. But as we talked about, that only works if I am in a place where I can view the desktop. It is in my current folder. So basically the only place this would work is from my home directory right here. But if I go to /, I'm not going to be able to just cd into desktop. I can't autocomplete. There is no desktop right here. So I need to use an absolute path, and I could do the full long name, cd/home/Colt/desktop like that, or I can do the slightly shorter version, use that tilde character, which refers to my home directory /desktop. Okay, moving on. The next command we'll cover has to do with making directories or making folders. It is mkdir, or make dir, however you want to pronounce it. It is short for make directory, and that's exactly what it does. It's the command we use to make folders. So the basic way we run it is make directory, or make dir, space, and then some folder that we want it to create for us, and it will create that folder. So let's try it. I'm going to cd just onto my desktop. I'm going to clear, Control L. And I'm going to make a new folder here. I'm going to make a folder called Greenhouse. I have a new greenhouse, actually, and I need to manage the crops that I'm growing and starting seeds and bills and maintenance and timesheets for employees. I don't know. That's the story I'm going with. I'm going to make a folder called Greenhouse on my desktop. So I'm on the desktop, right? PWD. There's no folder called Greenhouse. You can see it's alphabetical. It goes from Great Gatsby, grep, exercise, keys. So if I run make directory and then Greenhouse, if that's the name of the folder I want it to make me, I'll hit enter. We don't see anything happen, but if I type ls again, we now have a folder called Greenhouse. And if I just move this out of the way, you'll see on my desktop, there's Greenhouse. It's totally empty. It's an empty directory. So I can cd into that folder, and that's exactly what I'll do. Cd into Greenhouse. Whoops, I hit enter too early. Greenhouse, there we go. I use tab complete again. And now I'm in here. So we can also make multiple folders at once. You just separate their names by spaces. So I'm going to make a winter and summer directory inside of Greenhouse. Make directory winter and summer. So I can have, different schedules for what I'm growing in summer and winter. I'll type ls, and we see those two folders were just created for me in my current location, right? That's all I specified was summer and winter. I didn't say any fancy path, but what I can do is actually provide, if I wanted to make inside of summer, I wanted to make a folder called, how about, seeds. I could do make directory, summer, /seeds. So I'm inside of Greenhouse, but I'm not inside of summer. So in other words, I'm right here in this folder. I'm not going to go into summer and then make a folder in two separate steps. I'm doing it in one step. I just provide a path, make the seeds directory inside of summer. I'll hit enter. Okay, type ls. I don't see it, but if I do ls summer, there we are. I'm looking inside that summer directory. There's my seeds folder. Okay, now one last thing I'll show you. There's an option that's pretty common, which is -p, which allows us to make nested folders. So why don't we just take a look at the man page, man for make directory, and we'll scroll down. Here's p, or the long form -- parents. It says no error if existing, make parent directories as needed. So let me show you what it means when it says no error. So inside of the winter folder, which I'll just point out here, graphically, I want to make a seeds folder. And inside of seeds, I want to make a lettuce folder. So if I try and do that all at once, I'm inside of greenhouse. If I do make directory winter/seeds, let me just expand this window a bit here. Winter/seeds/ did I say spinach? No, I said lettuce. If I hit enter here, I get an error. It says can't create such directory. It runs into a problem because it expects that winter/seeds already exists, and it thinks it just wants us, or we just want it to make lettuce. That's not the case. I want it to make seeds and lettuce, but seeds doesn't exist. It freaks out. But that's where the -p option comes in. So make directory -p winter/seeds/lettuce. We're now telling it make any of the needed parent directories along the way to make this lettuce directory. We don't get an error. And if I type ls here, we don't see anything. But if I do a ls winter, we see seeds. If I do ls winter/seeds, we see lettuce. So it successfully made that nested directory and any necessary directories along the way. So here's, if we go back, winter, it made me seeds, and inside of that, it made lettuce. So that's the -p option, and that's really all there is to make directory. So mkdir followed by whatever directory you want it to make, and some location for that directory. Often, it's just your current location, but you can provide a path, a destination as well. So if I wanted to make something all the way back in my home directory, which again, I can use tilde as a shortcut, I could say make directory tilde/ blah, blah. I'm going to delete this once we learn how to delete folders. I won't see anything here. But if I go all the way back to my home directory, there it is, right there. So we can provide a relative path, an absolute path. We just give it some destination to make a folder, and it makes it for us. That's make directory. The next command we'll cover is touch. So touch, unlike most of the other commands, doesn't really tell you a lot about what it does, or its name doesn't indicate its most common use. Make directory makes a directory, change directory changes directory. Touch is used, most of the time at least, to create files. So there's no create file or make file, it's just touch. So we'll talk about where that name comes from in a moment, but let's just try using it. If we run touch and we provide it with a file name that doesn't yet exist, it will make that file for us. So let me go to my desktop. I made a greenhouse folder, didn't I? And then summer and winter. Let's cd into summer, cd into seeds, and let's make some files here. So let me clear my screen. I'm going to make a file in here. There's nothing at the moment. I'm going to make a file called, how about squash? So squash, I'm going to have a file full of different types of squash seeds, I guess. So if I just run squash as is, that's totally fine. Squash, if I type ls, it made that file for me. I'll just show it to you also visually. If I go to my desktop, I'll go to greenhouse, if I can find it, summer, seeds. Here's my empty squash file. I can open it. It's completely empty. Okay, so that's one option. I can also provide an extension as I'm making a file. So if I want to make a txt file, I can do .txt. So let's make another one. How about berries? How about just melon? Another summer fruit. .txt. And I now have a txt file called melon.txt. Now, it's important to note that the extension you provide, it does depend on the exact operating system you're running, but the extension does not indicate, it's not what's used to determine the actual file type of a brand new file. So these are all empty files. I could make a PDF file if I wanted to. Touch apple.pdf. It's not really summer, but if I type ls, we've got an apple.pdf. But they're all just completely empty at this point. If I look at any of these files, they are just plain old empty files at the moment. Of course, I can put stuff in them. I can change that extension. There's all sorts of things we can do. So let's try another example. I'm on my Mac here. I'm going to touch multiple files. So in this directory, it's called colors. I have a colors.txt file. I'm going to make a couple of new files. Let's go with red.pdf and then a space, orange. Let's see, how about PNG? And then yellow. We'll do a different extension here. How about an Excel, XLS? I type ls. Those files were created. They're all completely empty. Now here is, I'm on my Mac. This is Finder, the graphical user interface. I've got red.pdf, orange.png. If I try and open one of these, just with my mouse, on a Mac, it does try and use preview. It does think that it's a PDF, and it says it's empty. I don't know what to do with that. If I try and do a PDF, it does use a PDF reader or PDF viewer. But again, this is just on my Mac. If I go back to Ubuntu here and I open up a PDF, it just opens in a text editor. If I open up, if I make a PNG file, touch, what's another fruit? How about berry.png? If I try and open that, oh, it uses the text editor as well. Okay, so it does vary from one system to the next, but the point is we just make empty files with touch. Now let's talk about when we provide a name of a file that already exists. So if I run touch berry, again, I can do that. I can just hit the up arrow. It's not going to seem like it does much. It doesn't make me a second file with the same name. That would be a problem. What it does instead is that it actually is going to update the timestamp of the file. So it touches it. If we run man touch, always a fun command to type out, man touch, it actually says its main purpose is change file timestamps, update the access and modification time of each file that we provide. So it says here, secondarily, a file argument that does not exist is created empty. So that's why it's called touch, rather than make file or create file or something. Its main purpose, at least historically, is to change the access and modification times of a file. And then, also, if that file doesn't exist, it will make it as an empty file. So how do we know, or how can we view the access and modification times? If we remember ls-l, that flag, if we take a look at berry.png here, right there, October 15th, 1348 is the modification time. That's ls-l is the long listing format. So 1348, let's see, it's now 1350. So if I try and touch berry.png again, and I do ls-l, we now see it's showing October 15th, 1350. So it does in fact update that modification time. But most of the time, 99% of the time that I use touch, it's to make files. And I can make a bunch of them at once, as we saw. Just provide a bunch of file names separated by spaces, and it will make them for you. Okay, so we saw how to make files and make folders. Let's talk about destroying things. So to delete a folder, we can use the rmdir remove directory command, rmdir, followed by the name of a folder or a path to a folder that we want to delete, or multiple separated by spaces. However, this will only work if the folder is empty. So over here, I don't have any folders. Let's make a folder, make directory delete me in all caps. There it is. To delete it, one option is rmdir delete me. I type ls and it's gone. But if I back out and I try and delete the seeds folder, which is not empty, rmdir seeds, we get an error, failed to remove seeds, directory is not empty. And that's really all there is to rmdir. It removes empty directories, only empty directories. We'll see another command we can use to remove directories that have stuff inside of them. So next up, we're going to talk about the rm command, rm for remove. Let's take a look at the man page. It says we can use it to remove files or directories. So we saw how to use rmdir. It only works to remove an empty directory. I've got this seeds directory, rmdir seeds. No luck, it's not empty. All right, so this is where the rm command comes in. I'm going to show you how to use it to delete directories in just a moment, but we're going to start by deleting files. So I'm just going to make a couple files with touch. How about cat, dog, carrot, blue? All right, so I have these 4 files now. I can delete them using rm followed by, let's do blue to start, the name of a file. And that's it. It is gone. Now it's very important to note, there is no intermediate recycling can or trash can or something, some sort of bin we can go find all these files we've deleted. They are just completely gone. They're just vanished from our entire system. So that can be a bit of a scary thing if you're not careful with what you're deleting. So you definitely want to make sure you're only RMing things that you mean to RM. But the flip side of that is that it's very fast, powerful, quick, and easy to delete things, just as long as it's not too easy and you slip up. So we can delete multiple things, multiple files, if we just separate them with spaces, of course, like that. Carrot, cat, and dog are all gone. So that's the basic use of RM. I'll show you one more. There's a couple of flags I want to talk about. The first flag is -v. This is actually a trend. There are many commands that support a -v for verbose. That option, in the case of RM, will give us some verbose output that basically explains what it did. If you notice here, we run it, we deleted 3 things, but there's no feedback. It's just silently deleting them. We had to look to see, are they gone? Well, if we use -v, I'm just going to remake my 4 files again. If I use -v, so rm carrot cat dog -v for verbose, now it just tells me what it does each step of the way. Removed carrot, removed cat, removed dog. Pretty straightforward, hopefully. But the end result's exactly the same. You do not need to have that, of course. It's just something you may want to use. Some people like to use it. And like I said, there are other commands, like when we see copy, CP, and move, MV, we can use -v for verbose output, and it will tell us, just copied this file, moved this file, renamed this file, removed. Okay, so that's one flag, -v. The next thing I want to talk about is using RM to delete a directory. So we talked about RMDir does not work on seeds or any folder that is not empty. So that must mean RM will work, right? Let's RM seeds. Oh no, cannot remove seeds is a directory. But I thought the whole point was, RM could delete a folder that has stuff in it. Yes, that is the point, but we have to use a flag. And the flag we need to use is the R flag for recursive. So if I do man RM again, I'll scroll down a little bit further, R. So we can do lowercase r, uppercase R, or -- recursive if you really have a lot of time to spend. And what this will do is it tells the RM command to remove directories and their contents. So that could be other directories and further nested directories. There could be hundreds of levels of directories nested down. Remove them all. So here's how we would use it. If I want to remove the seeds directory, this is what it has inside, remember. It has 4 files. And I want to remove that entire directory. It's just rm-r seeds. And once again, there's no feedback. I could have added -v and it would tell us more. But now it is completely gone. That's it. So I'm going to make a directory again. We'll call this zoo. Let's cd into zoo. I'm just going to touch some random, animals, cat, dog, snake, jaguar. Okay, so I have that zoo directory now. I'm going to back out again. This time I'm going to delete it with rm-r, but I'm also going to show you a new flag, -i, for interactive. And interactive is going to prompt us and ask us if we want to delete each file or not. So if we do -i here, and then the folder, which in this case is zoo, now it's asking me, do you want to descend into this directory zoo? So do we want to go inside and see what's there? I'm going to say Y for yes, or if I said no, then we kind of end it all, but I'll do Y. Do I want to remove regular empty file snake? Yes. Cat, Y for yes. Let's keep jaguar, so I'm going to say no. Dog, yes. And now it's asking me, do you want to remove the directory zoo? I'm going to keep it. So that interactive mode allows me to make decisions. If you're deleting, 10,000 files, maybe not the best option, but that is a flag we can use, -i, to interactively decide what to delete and what to keep. So now if I look at zoo, it only has the jaguar file inside. One more quick demo I want to show you. I have a, let's see, where did I put that? On my desktop, a directory called meals. And inside of meals, I made 52 folders, one for each week of the year. And inside of each week, if I just pick one, like week 35, there is a folder for each day of the week. And for each one of those days, there are 3 files, breakfast, lunch, and dinner.txt. So we've got 3 files for each day of the week for 52 weeks of the year. It's a lot of files and folders nested. I'll show it to you here. So this is the meals directory. All these different weeks, pick one, pick another day, all those files. So there's a lot of stuff going on here. And I just wanted to show you that I can delete the entire thing very easily and very quickly, all those nested folders and files using RM. So I'm going to CD back a couple levels, one more and one more. Just to reiterate, I don't need to do CD ... CD ... CD ... to go back 3 levels. I could have done that right there, or I could have just said, take me to the desktop specifically. So this would work from anywhere. This CD ... CD ... CD ... only works if I'm 3 levels away, 3 levels burrowed down from the desktop, if that makes sense. This will work from anywhere. Anyway, I have this meals directory. I'm going to remove it. I need to do a -R, and I'm going to make it verbose so you can see exactly how many things it removes in a single go. So this is just one command. Remember, no recycling bin, no trash can. These files are gone. So you obviously want to be careful. But here we go. RM-R for recursive. So we can delete a directory that has stuff in it. And -V for verbose. And if I scroll up, I'm going to be scrolling for a long time. Lots and lots of files and folders deleted in a split second. So that's the RM command. It also does work to remove empty directories. So in that sense, you kind of never have to use rmdir. I just show it as a quick command that you may encounter. Some people like it because you know that you're not going to be accidentally deleting stuff that has a bunch of contents inside of it, but you could just use the rm command in general to delete files, delete empty folders, or delete folders full of a bunch of stuff, as long as you use the -R option. All right, so that is RM. The next command I'll show you is one I use all the time on my Mac. It is called open, and it will open a folder, open a file outside of the terminal in the sort of graphical world of our machine. So if I make a bunch of files, like I don't know, how about purple? I'll just make one.txt. If I now want to do something with that file, I don't know, I want to view it in Finder. Well, I could navigate to it and figure out where this is, or I can do open. I could do open dot, that will open the current directory. And here we go, a Finder window with that directory. But I could also say open that particular file. And it opens it up in the default application, which is just a text editor on my Mac. But if I had some other file, I can find an example here. If I go to my desktop, which I edited out, I've navigated here, I've got a file, let's see, I've got a PDF file. If I open that, it opens it up, in my case, using a PDF editor, the default, what it would open with if I double clicked. Anyway, so that's the open command, but it is Mac specific. So again, I can do things like open dot to open the current directory. I can see all my files and work with them here if I need to. I can open a particular file, and it's pretty smart. But if I try this on Ubuntu here, I've got 2 directories here. If I try and open that, it's going to complain to me. It can't do it. It doesn't know that command. Now there is an alternative, which is xdg-open. And there we go. It opens up, in this case, this folder for me. If I have a file, let's call it touchtomato.js. If I do xdg-, it's a bit of a annoying one to type, but open tomato, it opens up the text editor, and I can start working on this file. Now, you may need to install it, just to be clear. Like if on WSL here, if I try xdg-open dot, well, I need a dash there. It complains and it tells me I need to install it using this command. So you can install that if you want, but this is one of the main differences here. Open is a Mac-only command. It might be one of the, I think it's the only one we cover in this video that is different between Mac and Ubuntu or Linux. The next command we'll look at is mv for move. This is how we can move files around. It's also how we can rename files. And that's going to be the first use case I'll show you. if we run mv followed by an existing file and then a space and then a new file name, what this will do is move pair, turn it into new pair. It will rename it. So let's try an example here. Whoa, got a lot going on here. Why don't I make a new directory in here? I'll just call this commands. I'll cd into there. Okay, I'm going to make a file in here, and I'm going to call this my journal. But I spell it wrong, like that. And I want to rename it. I can use move. Let me just show you. There it is. I can use move and then the incorrect name, journal.txt, and then the new one, just like that. And again, you may not get this verbose output. That's just a setting I have. But if we type ls, we see journal.txt. Now, if you do want that verbose output just for any of these commands, like rm, if I do mv, I get the man page for mv. There's an option in here, further down, -v, which explains what is being done. So if you want to know exactly what's going on, let's say I want to rename journal, the correct version, I want it to now be an uppercase J. I don't know why. If you add -v, which mine have by default, you'll get that verbose output. Honestly, I only put that in there when I'm teaching so people can see what's going on. I don't really care to get that confirmation. It's going to work either way. And we can see it's been renamed. Now, we can also use move to change the location, not just rename, in the same directory, but to move a file back a directory or into a completely different directory. So let's find an example of that. Let's just make a directory here. I'll call this one, I don't know, stuff. And I realized, shoot, I really should have made that journal file inside of stuff. Well, I can move it in there. It's pretty easy. I can just do move the thing I want to move, and then the move command is smart enough to know that if the last parameter, the last argument, is a folder, it will be the destination folder. So I can move journal into stuff. And if I type ls, I don't see journal anymore. If I look inside of stuff, it's inside, or journal is inside of stuff. I can also do that to multiple files at once. So if I touch, I don't know, about pie and cake and cookie, sure, I have these 3 files. If I want to move them into stuff, I can do mv, cake, cookie, pie, and then as long as stuff comes last, it will be the destination folder. And there we go. They are moved into stuff. Now there's more you can do with move. You can move folders around. You can rename folders. So if I want to rename stuff instead to be stuff in all caps, move stuff to be stuff. There we go. I just renamed it. That's probably all I'll show you for move. It's pretty powerful. I use it all the time to move things around. I could move this entire stuff directory onto the desktop if I wanted to. I could do move stuff and then just have it go back one directory. Right now I'm on this commands folder. I want it to go onto desktop. It's not here anymore. I'll cd back. And here it is on my desktop somewhere. There it is. This is the one, the uppercase stuff. All right, so that's move. The next command I'll cover is cp, which is for copy. We can use this to copy a file or even copy folders. So if I make some file, I'm on my desktop here. There's just too much stuff going on. Let's go back to my stuff directory. Okay, so I've got this journal file. If I want to make a new copy of it, let's say for today's journal, sure. I'm going to copy it. I can do cp, the thing I'm copying, which is journal, and then the destination for the copy. So if I want it to be in the same folder, then I don't need to do anything, just provide a name. So how about today journal or something like that. And that makes me a copy. So I have journal and I have today journal.txt. Now these are all empty. So it's not that useful to show, but if they had content inside of them, like I'm on my Mac here, I have this Linux commands handbook.pdf. If I want to make a copy of that, cp Linux commands handbook.pdf, and give it a new name, how about handbook.pdf, just like that. If I type ls, well, there's going to be a lot of stuff on here, but there is a handbook.pdf file. And if I open it up, or just, yeah, I'll open it, sure. You'll see that it is a full copy. So it's the entire Linux handbook here, all these commands we've been covering. So it doesn't just copy empty files. That's very important. We can also copy entire directories. So let's go back to Ubuntu. Where are you? Here we are. I've got this stuff directory. Why don't we copy the entire stuff directory? So cp stuff, and then I want to make a directory called stuff copy. Well, if I try that, we have a problem. It says -r not specified, omitting directory stuff. It's not going to copy this. Well, if we take a look at the man page for cp, it tells us, if I scroll down, there is a -r option, which, just like with remove, rm, stands for recursive. So if we want to copy the contents of a directory and any nested directories and their contents and so on, we need -r. So let's replace this. Let's rerun it one more time. cp -r stuff copy. I have that -v verbose on by default. Again, you can turn that on if you want, or you can just run it with -v if you really want this output. But here we can see it made a copy of the stuff folder and all of its contents. So if we take a look, here's my stuff copy. And inside of it, we have all of these files that have been copied as well. So we can make copies like that. I can also move as I'm creating a copy. So if I want a copy of, I don't know, Song of Myself, and I want it to go inside of stuff copy, or inside of stuff, wherever. Let's go to my desktop. I can do copy song. Is it capitalized? Yes, it is. Song of Myself, long poem. And let's actually put it, sure, let's put it inside of stuff. So stuff / and then I'm going to call it SO, Song of Myself. Sure, psalms.txt. All right, so I'm going to copy it, but I'm also moving it at the same time because where I'm copying it to is a different destination. I won't see psalms in here, but if I look in stuff, cd into stuff, no, where did I put it? Well, I'm an idiot. I put it inside of stuff with lowercase. How confusing. It's not in here. It's going to be in this one. So if I cd into lowercase stuff, there it is, psalms.txt. All right, so it is there. And that is a copy of that file. So that is the cp command. The next command we'll take a look at is called head. So let's look at the man page for head. It says that it outputs the first part of files. Head and tail are often used to refer in programming to two different ends of a structure, in this case a file. The head of a file is the beginning, the tail would be the end. So it's a really simple command. It just prints out, by default, I think it is the first 10 lines of a file, but we can actually specify an exact number using the -n option. But let me just show you. So I've got this very long file in here, which is songofmyself.txt. It's like hundreds of lines. It's a long poem. If I run head songofmyself.txt, it just outputs the first 10 lines. Now, as we saw, I can provide the -n option followed by a number like 100, and it prints the first 100 lines from the beginning of the file. So there we go, 100 lines. And that's kind of all that there is to head. Now, there's also a command called tail. Let's look at man tail. And it, unsurprisingly, probably, outputs the end of a file. So by default, it's the last 10 lines, but we can also provide an exact number using -n. And there are some other options here as well, but let's just start with that. So I'm going to do tail songofmyself.txt. Here are the last 10 lines of Song of Myself. But I can also say I want the last 20 lines. And there we are, I get the last 20. Now with tail, I'm on my Mac now, there's one option that we don't have with head, which is -f. Where are you? Here we are. -f, it says it causes tail to not stop when the end of file is reached, but rather to wait for additional data to be appended to the input. Basically, it's going to read the end of a file and print it out, but then also keep printing out any new additions to the end of that file. This can be useful for log files, output files, error logs, things that are changing and you want to monitor them. If I just do tail, this is on a Mac at least, this system.log file. It doesn't matter really, but it's a file that contains a bunch of stuff. I honestly don't know what half of it is. And if I don't have that -f option, it just stops. This is the last thing printed out. But if I add that -f in there, whoops, I need to make sure I put -f in there first. Now my prompt does not come back. This file is being printed out, the end of it is being printed out, and if I do something that would add to that log file, like if I make a new window, like I just did, I'll do it again, you can see that that log file is changing. Content is being appended to it. So I'm getting a live, and as I close as well, you can see things are changing. I'm getting a live update as I make a new process or I kill a process from this system.log file. Whereas if I had just, I can get out of here by the way with Control C, but if I had just done tail without -f, it's not live. It just stops. It shows me exactly what's at the end of that file right now, but with -f, it keeps listening and keeps updating the output. So that's tail. So the next command I'm going to show you is one that I don't really use very much. I'm showing it to you actually because it helps illustrate some other concept. So the command I'm going to show you is called date. It's really straightforward, D-A-T-E, and it just prints out the current date and time. Let's see, I'm sure there's some other options and different things we can do. We can specify how it should display the dates. Honestly, we're not going to go into it because, as I mentioned, I don't use it very much. It can be useful, though, if you're writing a script and you need to get access to the current time or the current date, day of the week, that sort of thing. Anyway, the reason I'm showing it to you is because I'm using it to illustrate something that is not a standalone command. We're going to talk about something called redirection. So this greater than sign right here, we can use to perform something called redirecting standard output. So the date command, or really any of the commands we've seen, if I do ls, not la, ls, or I do date or pwd, all of these generate output. And that output by default shows up in our terminal, right? It's printed out as text here. But we can actually redirect where that information goes by sending it to a file if we wanted to. So I can take the current date and store the result instead of printing it out, store it in a file. And to do that, I use the greater than sign. Again, what we're doing here is redirecting standard output. Okay, so let's make a file. I'll show you, we don't actually have to make a file first, but I'm going to make an empty file. I'll call it today.txt. There it is, today.txt. All right, so what I'm going to do next is redirect date. So again, the date command, greater than sign, today.txt. And this tells the terminal, run this command first, but whatever output we get, don't just print it out. Instead, we're redirecting the output to this file, okay? And we don't see any output. Nothing is printed out. If I type ls, there we are. We see today is still there. Now, in a moment, I'm going to show you a command we could use to read this file very easily, but we do know head. We've already seen that, so I could do head today.txt and take a look. We see that it contains that text. So what do you think will happen if I recall this line and I run it again? So take the current date, whatever that is, that output, and send it over to this file. The file looks like this right now, right? If I run it again, we'll get a different time. It's still Friday, the 15th of October, but it's now 4:27. So this should change. But what you'll notice is that it actually ends up replacing the contents of that file. So it's not added as a separate line, right? We don't have two dates in there now. It ended up replacing the entire contents of the file. So this is very important. If I had a lot of stuff in there, for example, if I navigate back, I have this, let's see, stuff directory, lowercase stuff. I have this song of myself.txt. You do not need to follow along with this, but this file contains a lot of text. If I just look at the first 10 lines, it's the entire text of that poem, Song of Myself. Now, if I try and redirect something in there, I can take the output of pwd, for example, and redirect that into songofmyself.txt. Now that is the only thing in that file, the output of pwd. So we have another option, which is to use a different operation, very similar. We use two greater than signs, and this allows us to redirect standard output while also appending to a file instead of overwriting the file entirely. So if I just ran, pwd and then two greater than signs into this file, let's do it a couple times. This is silly to do, but if I take a look at that file, it now contains, 5 different lines. Let's take the date and redirect it into there. Let's take who am I and redirect it into there. Okay, now let's take a look at that file again. And you'll see it contains the output of pwd 5 times, the date, and then who am I, which in this case is Colt. Let's do date one more time, or a couple more times. Let's run head, and you can see it did not overwrite the entire file. It just appends onto the end. So, date I don't use very much at all. Redirection, though, both with a single greater than sign, which overwrites a file, and two greater than signs is really, really common. The last thing I'll mention is that you can do something like this, like date, redirect into today.txt. That file does not exist in this folder. If I take a look, there is no today. But if I do date, redirect into today.txt, we now have a today file. It made it for us. So the file does not have to exist in order to redirect output to it. It will make that file for us if it needs to. All right, so we can do it with the date command. We can do it with really any command that generates output, as we saw. I mean, I could do, if I wanted to, ls or ls-l. That gives me a lot of text. I could take that and then redirect that to a new file called, contents. How about that? And if we take a look at contents, we'll just use head for now. This is what the first 10 lines are. There may be, I think there's some more that's missing, but we're just doing the first 10, and we can see what is inside that file. So that's the basic concept of redirecting. And then, of course, if we use two greater than signs, we are redirecting by appending to a file. The output is appended to contents, and now if we do head, we'll probably need to specify, I want, how about just 40 lines of that file? We can see all of this is in there. All right, so next up we have another command called cat, C-A-T. And let's start by just taking a look at the man page for cat. The name cat comes from the fact that it concatenates files, cat. But the first use I'm going to show you is something slightly different. On its own, if we just run cat, I'm just going to clear here, cat and then a file name, like I have this song of myself. I actually don't think we overwrote that, didn't we? But if I do cat and then a file name, it just prints the contents of that file, in this case, to my standard output to the terminal. If I have, we had that contents file that we just made, cat contents, it gives me the entire file. So it doesn't, like head gives us the first 10 by default. We can specify the first 20 lines, the first 30 lines. Tail gives us the last 10, the last 20. Cat gives us the entire file. So I've got this song of myself file, very long. If I cat song of myself, it prints out the entire thing. There's a lot here. I'm scrolling for a very, very long time. All right, so that is something we can do, but that's, sometimes I'll use that if I want to just check on, what's in that file. I don't remember. What's it look like? We can do that, but there's a lot more we can do with cat as well. Remember, the name cat comes from concatenate. So we can actually provide more than one file name, and it will print the contents of both of those, or 3 or 4, however many files. It will print all their contents together. So on my desktop, I have quite a few messy files here. I've got one called letters. So I'm just going to cat letters. All right, it just contains letters. And then I have this one called words. I'm going to cat words. And there we are. Okay, so I can cat them individually, or I can cat them together just by separating them with a space. And now we end up with one output. Again, not very exciting, but 2 different files were read and then concatenated together in this output, smushed together. So that doesn't seem that useful, but where it gets more exciting if exciting is a stretch, but where it gets more sometimes useful, is that we can then redirect that output to another file. So I could make one file that is a combination of 2 or 3 or 4 other files, or it doesn't have to stop at 4. I just don't want to keep saying numbers. But we can take multiple files, concatenate them together, and take that output and save it into another file. So here's an example of that. I have 3 different shopping lists. One for the butcher. We can just take a look at that. I need ground pork, ground beef, sausage, skirt steak. I've got one for the feed store for my animals. I need to get chicken scratch, chicken feed, oyster shells. And I've got one for groceries, milk, eggs, butter, onions, tomatoes. All right, so I want a master list. Still contrived, but I want one list that I can take with me. So I can concatenate all of them: butcher, feed store, groceries, and then I will take that. First, we can just see what it looks like. Here's the concatenated output. But instead of printing it, let's redirect it into a file. We'll call it everything, if I can spell everything. Okay, and now we have a new file called everything. Let's take a look at it. It contains the results of those 3 other files being concatenated. So that can be useful, right? We can take multiple things, stuff them together, and put it in another file. But as we'll see later, we can also actually take multiple things, concatenate them, and send them to other commands, not just send them to a file. So we'll cover that later on when we talk about piping. One last thing with cat that I'll mention is that we can use the -n option to get line numbers. So maybe not that useful here, but if I go back, we have that super long Song of Myself poem. If I do cat-n Song of Myself, pretend this is a file with some code and there's a problem in here, I can find that line number and then tell my coworker, hey, it's on 1741. You would probably be in an editor, but we'll also learn about some other commands like find and grep, which allow us to search for things. So we'll get there. There are valid use cases for wanting those line numbers to be available. All right. The next command we'll look at is called less, L-E-S-S. Less is used to read the contents of files. It gives us a nice interactive UI where we can scroll, and it's just a lot easier to work with a file compared to looking at the contents that is printed out from cat. So just as a reminder here, I've got this super long file, Song of Myself. If I use cat, it prints out the entire thing, and I guess that's sometimes useful, but in a super long file, I've got to scroll forever. Yes, I could use head or tail just to get, the very top or the very bottom of the file, but this is a lot of scrolling. So if I wanted to actually go through this, I wanted to read the entire poem or look at a massive log file from scratch all the way at the beginning, I could use cat, scroll to the beginning, and now just use a terminal and scroll down. But it's not that easy. It's not a great interface. But if I use less, followed by the file name. So any file name, but a long one is ideal because you'll be able to see how useful it is. Less songofmyself.txt. Now my screen changes. It didn't just print out the entire text to my terminal window. Instead, it opens up the less program where I see a page, and then I can scroll down with arrow keys, just like the man pages. So if you remember with the man pages, if we open up man some command, our prompt goes away. We're transported to a new world of man pages, and we can scroll. I can hit space to go one page at a time. And there's quite a bit more we can do in less. But first, most importantly, to get out of here, Q, just like the man pages. So my history, my terminal is not cluttered with thousands of lines of text. So that's one benefit. But also, of course, I can read things and scroll at my own pace. I can also do things like search. So if I want to search in here, my cursor is right here. It's a little hard to see. If I type a / and then I type some phrase or something I'm looking for, I don't know, let's look for green. I don't know if green is in here somewhere, but let's see. I'm going to type green and hit enter. And there we go. This is the first match, the sniff of green leaves and dry leaves. So that's one thing we can do. By the way, I mentioned you can scroll one page at a time down by hitting the space bar. We can scroll up one page at a time by hitting B. So B and space. We can also use the arrow keys up and down. We can jump to the end of the file, I believe, by hitting G, capital G. Yeah, we need Shift G. It takes me to the very end of the file. And then lowercase g takes me to the start. So here's the very beginning. uppercase G takes me to the end, and as always, Q is how I can quit. So this is great to work with long files. It's just easier to navigate. You can search for things. Unlike if you're just looking at an entire file using cat, it's just all vomited on your screen all at once. So that's less. The next command we'll learn is called echo. E-C-H-O. It's very simple. It does one thing. It takes whatever value, whatever argument we pass it, and it echoes it back. It just prints it back. It outputs it. So that might not seem useful. Let's get out of here. Let's clear. If I just echo hi, well, it just echoes hi back to me. It prints it out. So yeah, it is not that useful when you just run it like that. But one really useful trick is to use echo with a piece of text and then redirect the output to a file. So this is a great, really fast way of making a new file that contains some little bit of text without even having to open up the file. So if I needed to make some config file and it needs to contain, I'm just making this up, but it needs to contain something like, username equals Colt, something like that. It needs to have one line in that file. Well, I could make an empty file. I could open it up and then I could put this in there, save it, close the file, or I can echo it and then redirect to a file that doesn't even exist yet. So that file, let's just call it config. We'll just do txt. So it's going to take this argument, it's going to echo it back, but instead of printing it to the terminal, I'm redirecting it to a file that doesn't even exist. It will make that file and put this piece of text in it. So now we have a config file, and if we use cat to look at it, there we are. It contains that line. And I can also, if I needed to add something to it, I can do the same thing where I can append with 2 greater than signs. So if I needed some other config in there, I don't know, how about key equals that? That is now appended into our config file. If we take a look, there we are. It has 2 lines of text in it. So this is not how I would recommend editing files, but if you need to make something quickly or just add a small thing to a file quickly, this is a really great way of doing it. Echo some piece of text, redirect it into a file. So to summarize, echo on its own, some piece of text, it echoes it back to you on the terminal, it just prints it out, but we can also redirect that, and it's a great way to add some text to a file in like 2 seconds. So the next command we'll cover is called WC. It's short for word count, and it does just that. It counts the words in some input. For now, it's going to be a file, but we can actually provide other inputs, and it does more than just word count. It actually will count the bytes and the lines. So if you remember, I have this very long Song of Myself file here. I want to know how many lines are in it. Well, if I run WC and then Song of Myself, it tells me, well, there's 3 different values here. The first one is the number of lines, 1,757 lines. The next one is the number of words. And then third, this little chunk here, that is the number of bytes, and then the name of the file. So if we look at the man page for WC, you'll see that it tells us the order again, how many lines, how many words, and how many bytes. We can also say, actually, I just want the lines. So we can use -L. Or I just want the number of characters, -M. Or the number of words, -W. So let's see how many lines. I don't want all that other stuff. I'm going to do WC-L, songofmyself.txt. There we are. I want to know how many words, -W. Song of Myself, we get 15,767. Okay, so that's one way of using word count. But I'm also introducing a new concept right now, something called piping. So we're directly passing right now a file to word count. But with piping, we can do something very different. We can actually take the output of one command and pass it as the input to a second command. So we saw how to take the output of some command like ls and redirect it to some file. This is taking output and then putting it in a file. But what I'm talking about is taking output of a command and passing it to a second command. So what if I wanted to know how many files are in here? So if I do ls-l, this is a massive chunk of text, right? I can take this and I could, I guess, take it, redirect it to a file and count the lines in that file, or I can use piping. So it's called piping because we use the pipe character located above the return key on the right side of my keyboard. I take the first command, ls-l, and then instead of just printing out the output, I want to pipe it to the word count command, wc. And take a look at that. We see the number of lines, new line characters, number of words, and the number of bytes. So what we just did was take ls-l. I could even let's do al. That will include hidden files if I have any here. There's just 2 of them, but we have 64 lines now. So that's just one quick example. But we can also do things like combine 2 different files using cat and then pipe that to word count. And word count's not the only command we can pipe to. I'm just introducing that one first. I could even do date, pipe that to word count if I wanted to know how many bytes are in there or how many words. It's 1 line. I don't know if I'd really want to do that, but we definitely can. But I have a couple of, let's go actually to my shopping once again. And I have, if you remember, this butcher file and feed store. Well, actually, let's do groceries. So I have butcher and groceries. I want to know how many things I have to buy. So I'm going to combine those 2, groceries and butcher, with cat. So cat, groceries, and butcher. And remember, on its own, it just smushes them together and prints it out. But I'm not going to redirect it to a file. I'm going to pipe it to word count. And there we go. And if I just want the lines, that will tell me how many items, right? 1 item per line, and it says 9. And that seems correct, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 different things that I have to buy. All right, so that's an intro to piping. It will pop up again and again as I introduce some other commands that are really more useful when you pipe things to them. One more thing I'll show quickly. I can combine piping and redirection. If for some reason I wanted to take this output and then redirect it to a file called number.txt, I can do that. So this will run first, concatenate those 2 files, and then we're taking that information and piping it to the word count command, which is just going to give us a number of lines, in this case 9. And then, instead of printing that out like we did here, redirect it to a file called number.txt. There it is, number.txt, and if we look inside, well, it just has the number 9. So that's a quick intro to piping. Next up, we'll see some other commands we can pipe to. The next command we'll talk about is sort. So sort does what it sounds like. It sorts information. We'll start by just sorting a text file. So I have this, why don't we start with our everything file. So let's take a look at that. Okay, so it has a bunch of different items, and I'm going to sort them with sort everything.txt. Now this is not going to change the file itself. This is simply sorting the output. It's going to sort what it gets from this file. It will read it in, sort it, and print out the sorted information, but it does not store it in that file. And you'll see we end up with an alphabetical sort by default. So butter, chicken feed, chicken scratch eggs, ground beef, ground pork. It is case sensitive, so an uppercase S comes before a lowercase s. And you can actually tell it to not be case sensitive, I believe. If we look at man sort, there's an option in here for, where is that, ignore case, -F. But this is great. This is, sorting a file alphabetically, but just to reiterate, it is not changing that everything file. It is unsorted. Now, I could redirect, of course, so I can do this, sort everything, and then put it into a file called sorted everything. And now, if we look at that sorted everything file, it is indeed sorted. We also can tell it to sort numerically. So if I had a file that had numbers in it, okay, I have a file called nums I've just created. Nums. It just contains 5 numbers here. If I try and just sort nums as is, it doesn't do a numeric sort. It does, well, it sort of does. It compares, the first digit of each and a 2. So these both have a 2. That means I guess they come before 54 because that starts with a 5. But it's not an actual numeric sort. But we have the -n option that will now sort things numerically. And there are other sorts that we have at our disposal. We can reverse things with the -R option. So let's do that, -NR. You can see we now have 999 first, all the way down to the number 2. Another option that can be useful has to do with duplicate values. So why don't I echo 999, and I'll append that into my nums file. I'll do that a couple of times. All right. So now when I recall my sort for nums, there's a bunch of those 999s in there. If I want to only get the unique values, I can use the -U option for unique. So let's do -NU, and now I only get the unique numbers sorted. All right, so that's sorts. We can concatenate and pipe information to sorts. We can do all sorts of things, right? It doesn't have to be from a file, so I'll just show one more example of that. Let's take the butcher file and the, what's another file I have? Groceries. Okay, and if I want to sort those two, I can pipe that. Whoops. Oh, I don't know if you can hear my cat there. I can pipe it to sort, and there we are. It sorts what it received as its input. So it wasn't just one file. We took one command, cat, that gets an output. We pipe it over to sort. So there we go. I could also do things like if I wanted to know how many unique numbers are in this numbers file, right? Nums. I could sort nums, but I only want the unique. So -UN sort. Whoops, not sort. Nums. And then let's imagine there was like hundreds of them instead of, 5? I could pipe that over to good old word count and ask for how many lines. So take this nums file, only sort the unique values, sort them numerically, but instead of printing the value or the output to the terminal, pipe it over to word count, where we count the number of lines, and the grand total is 5. So this just is to show you that we can take sort and pipe its output to something. We can redirect its output to a file, or we can take some other command like cat and concatenate 2 files and then pipe the output to sort. So that's sort. Next up, we'll talk about the unique UNIQ command. Now the unique command is generally, at least when I use it, used in conjunction with the sort command. So unique is going to, let's just take a look at the man page first. It reports or omits repeated lines. So anytime you have a data set or a file that contains repeated information on different lines, and you're trying to either consolidate it or ignore repeated lines, we can use the unique command. So just show an example. I have a file here that I've just made called Fave Flavors. It was, let's say we run an ice cream shop. We asked our customers what their favorite flavor of ice cream was. And we got a bunch of different outputs, right? Chocolate, vanilla, strawberry, a bunch of vanillas, Rocky Road, cookies and cream. But there's a lot of duplicated values. Now, if I just run unique on this command, or on this file, Fave Flavors, well, that's weird. It really doesn't seem like it works because I see a lot of duplicated values. It seems like if it only gives us unique values, or it removes duplicates, we shouldn't see cookies and cream twice. We shouldn't see vanilla twice, or way more than twice. Well, what it does is it doesn't actually just remove all duplicated values. Instead, it removes adjacent duplicated values. And that might seem weird, right? So we've got strawberry. Let's take a look here. Chocolate, vanilla, strawberry, and then 2 vanillas. Well, if we look at the output from unique, we have chocolate, vanilla, strawberry, 1 vanilla. Down here, we had strawberry 3 times in a row. Over here, it shows up once in a row when we use unique. So it is going to look at one line and then the line after it. And if it's the same, then it's only going to print out one of those. So generally, I use this in conjunction with sort. So if I sort Fave Flavors and then pipe that to, let me just remind you what that looks like. It's alphabetical. So now they're all chunked together, right? Cookies and cream, Rocky Road, strawberry, it's all together. And then I can pipe that to unique. And now we just get the unique values because they were all in a row, and the way that unique works is it's only going to take one anytime there's duplicates in a row. But you might be thinking, didn't we just see there's a -U option? And indeed, there is a -U option for sort. It kind of makes this obsolete. But there's additional behavior to the unique command that can make it useful. For example, if I do man unique, there's an option which is -D, which will only print out the duplicates. So I only want the duplicates. Let's try that. Let's do, well, unfortunately, they're all going to be duplicates, aren't they? If I do this -D, every single one of these flavors appears more than once. But if I echo, how about mint into fave flavors? And let's do one more flavor. How about pistachio, or how about rainbow sherbet? Okay, so now we have two values that are not unique. So if I remove that -D, here is all of the sorted unique flavors. So we see a list of them. But with -D, now I only want the ones that are duplicated. So we no longer have rainbow sherbet and mint. Side note, I've always said sherbet my entire life, but I don't know. I was corrected on sherbet. So now I'm self-conscious. I guess I'm sticking with sherbet. So there's another option. Instead of -D, we can use the -U option to display non-duplicate lines. So the lines that only appear once. -U. And now we can see, oh, these are the flavors that only one person liked. In our case, we've got mint and rainbow sherbet. Everything else is duplicated, so we don't see it showing up. And then an even fancier option is that we can get a count of how many times each line appears with -C. So why don't I do that here? I'm going to do sort all the flavors, .txt or fave flavors, and then pipe that to unique, and then -C will give me a count. And we can see, all right, there's 5 chocolates, 6 vanillas, 1 rainbow sherbet. And what's extra fun is that we can actually take the output, instead of just printing it out, I can resort that numerically if I wanted to get a ranked list. Because they all start with a number, I can do sort -n. So sort all the contents of that file alphabetically, which groups them all together. Then take that output and pass it to unique, which is going to weed out all duplicated lines that are adjacent and give us a count for how many times each one appears. But instead of printing that out, pipe that to the sort command again, where we will sort by number at the beginning. And then we could even reverse it with -R, and we can see the most popular flavor, vanilla, so boring, all the way down to the least popular, mint, this is not accurate. I think mint is actually quite popular. But anyway, that is using piping along with the unique command. It's kind of a lot to take in. So if you just need to sort the unique values in a file, you can do the -U option. But if you want a count of how many times different lines appear, if you want to weed out duplicated values, or you only want an output that contains the values that are duplicated, you can use the unique command. Now, if you remember when I introduced the echo command, if you happen to be somebody watching this entire thing from start to finish, you may recall, at least, when I introduced echo, I talked about expansions and how later on I would cover this thing called expansions. Well, that's what I want to talk about now. What I'm about to show you is not specific to the echo command, but we'll be using the echo command to help illustrate how these expansions work. So when I say expansion, what I mean is that there are special characters and special syntax that we can use with various commands that the shell will interpret and expand into some other value. And probably the simplest example is actually something we've seen before, the tilde. Tilde expansion, if I just echo the character tilde. Tilde has a special meaning. I'll zoom in a little bit. As we've talked about, it is a shortcut that refers to our home, or my current user's home directory. So here, tilde is /user/coldsteel. Now, when we echo it, what we're actually doing is asking the shell, print out tilde, but it's not the character tilde, right? If it's in quotes, then we get the tilde printed out. What it's doing instead is it's expanding that character. It has a special meaning. Before it even runs the echo command, it's going to replace that or expand it to be this, and that's what it echoes out. So when we do things like cd tilde, again, the shell steps in and says, oh, I know that. Let me expand that. And it turns it into /user/coldsteel. And that is where we cd to. So I cd to tilde, it's the same end result. All right, so there's other types of expansion though, including $environment variable expansions. So in our shell, there's a bunch of environment variables available. Some of the more common ones are things like $path in all caps. If I echo that, you'll see that it's been replaced with a very long, yours may be much longer actually than this. It's not too bad. If I run it over here on Ubuntu, I think I have quite a long path here. Nah, not too bad either. So it takes this and it turns it into, or it expands it to the value of that variable. Now, if you don't know much about environment variables, don't worry about it. But here's one more example, user. That's an environment variable for the current username. Okay, now a more useful thing is path name expansion. So path name expansion allows me to use special syntax, special characters to match different path names. So we've actually seen this before, we just haven't called it path name expansion. I'm in a directory right now. Well, I'm in my home directory, aren't I? So there's a whole bunch of stuff here, different files and folders. Why don't I do this over on Ubuntu because I have some more files to work with. Okay, so when I type echo, I'm just going to use echo again because it's an easy way to see what the shell is doing for us. So it's just going to print back the expanded version of the star character. So if I wrap the star character in quotes, that's what we actually get echoed back. But if I don't have those quotes and I simply echo star, what I see is a list of every path name in this current folder. So every folder, every file name, like, Pokemon.txt, Word.txt, and then different folders like cleanup and copies. I'm just matching everything. So the star means every path here. But I can narrow it down and I can say star.txt. And we've seen this sort of thing before. Again, this is going to then be replaced with matching paths. So this was replaced with all of that. Now, if I do star.txt, it's only going to match something that starts with anything, but ends in exactly .txt. Okay, and so here we are. We see our matches that end with txt. Now, echoing them may not be that useful, but I can do things like ls-l star.txt. I want to print out long listing information about all text files in here, and there we go. I only see .txt files and all their information. So we also have another character we can use to match path names, which is the question mark. A question mark will match any single character. So this would match any 3 characters in a row. This would match any 4 characters in a row. So let me show you an example. If I echo, and I'll do anything, so the star matches anything, and then a dot, and then any 2 characters. So this looks weird, but it's saying anything that must then end with a dot, and then exactly 2 characters. I don't care what those characters are, but 2 characters. And we don't really match anything, do we? In this folder, I guess we don't have any. All right, well, let's try 3 characters. And now we're just matching all our .txt files and .zip files. It's not that exciting, but just as an example, if I were to touch app.py and app.js and main.js, all right? And then I ran our original version here, which is anything with a dot and then exactly 2 characters. Now we're matching those .js and .py extensions. So I'm echoing them. Again, that's not what we would normally do. We might do something like ls, or we could even do rm. If I want to remove all those files, this is kind of very dangerous, and I don't know if I would recommend this, but just as an example, I could remove those files that have 2 character extensions. That would be a very bizarre thing to want to do, just all 2 character extensions, but I can. rm star dot question mark. So remove all files in here that end with 2 character extensions. And I have it set up again automatically to ask me, prompt me if I want to. So I will say, yes, I'll remove all of them. Remove and remove. All right. So that's the basics of path name expansion. Next up, we have some other types of expansion. So we'll start by talking about curly brace expansion. Again, I'll use echo. When the shell encounters curly braces, and I provide a comma-separated list of values. So I could do something like, let's just do letters to start. A, B, and C. Okay. If I just echo A, B, and C, it's not going to be very exciting. But if I add something before or after, let's do ABC dot txt. Okay? What this is going to do is create every combination of A followed by txt, or .txt, and then B, and then C. And that's what we get. A.txt, B.txt, and C.txt. So whatever these values are, separated by commas, I can make files with them if I wanted to. The shell is going to take this and expand it first. So if I did something like touch, and then how about I did app dot, and then in curly braces, JS, HTML, CSS, and PY. If I wanted to do that, I'll run it with echo first so you can see what it would make me. App.js, app.html, app.css, app.py. And then if I wanted to actually create that, I could use touch. And that will make me all those files. So there's a bunch of stuff here. Why don't we narrow it down? Well, only ls things that end in 2 characters. Or how about app dot and then question mark, question mark, question mark. Or how about a star? All right, and we can see what we created. We can also do numbers and provide ranges. So if I echo 1.99, this is going to be expanded to the numbers between integers between 1 and 99. So I could create a bunch of files. How about day, and then let's do 1 to 365 if I was keeping some sort of journal. I'm not making files right now, I'm just echoing it. But the shell takes this, it expands it into this massive list of different numbers, or rather different names, day 94, day 95, and so on. And then I'm echoing it, but I could just as easily touch or make directory and create 365 different directories in a single line. Now, there are other types of expansion. We're not going to spend time talking about them, but basically the concept of expansion is that the shell intervenes before a command runs, expands some smaller thing, usually it's small, into a larger piece of text, and then passes that to some command. And we can use that to our advantage to craft short commands that results in creating hundreds of files, or deleting a whole bunch of stuff, or just matching a bunch of things by defining a pattern, like we saw. If we want to match, anything that, how about starts with the letter F and then ends in anything else, I'm just echoing it, and this is just echoing the paths that match this pattern in my current directory, but then I could delete them all. If for some reason I didn't want them to start with an F, I could delete them all, or I could move them all. I could copy them. There's a whole bunch of things we can do. Next up, we'll cover the diff command, which we can use to find the differences between 2 different files. If you've ever used Git, you probably have seen the git diff command. We will actually see what it relies on behind the scenes to generate a diff. But first, let's make 2 files, or at least 1 file, that is slightly different than another. So I have this ice cream flavor file, fave flavors file. I'm going to copy it. So copy fave flavors, and I'm going to make another file called fave flavors 2.txt. It's not very original. All right, so now we have 2 of them. And if I compare the 2 with diff at the moment, they are identical. There's no difference. So let's change something in fave flavors 2. Let's echo another thing in there. How about, what's another flavor? Let's just do mint again. And I'll append that, not with a single greater than sign, 2. I want to append to fave flavors 2.txt. Okay, so now that exists at the end of that file. Just that one extra addition of mint. So if I rerun my diff between those 2 files, this is what it tells me. 24A25 mint. And we could spend a lot of time talking about how this works, but to read this change command here, what it's telling us is that On the first file, line 24, on the second file, line 25 was added. So if we change the direction, if we instead compared fave flavors 2 to fave flavors just on its own, now the output says line 25 on the first file, line 24 on the second file was, I don't know if the D stands for deleted, I believe. So, appended, added, deleted. We can have multiple diffs too in a file. Just if I quickly change something in, how about in fave flavors 2? So let's open that up. I'm going to change something on line 3. I'm going to do strawberry and cream. All right. I'm going to save that file and close it. Now, if I do my diff between fave flavors and fave flavors 2, we see we get two different diffs, right? Two different things that were changed. On line 3 of both files, it was changed from strawberry to strawberry and cream. And then line 24 of the first file, line 25 of the second file, we added mint. Anyway, this is one way of using diff, but what's probably more common and more useful is to see both files side by side with -y. So that's one option if we pass in -y. Although in this case, way zoomed in, it's kind of disastrous, isn't it, on this screen size, because I've tried to make things readable. But if my font were quite small, you would see it side by side. And then lastly, we have the -u option, which is what Git uses behind the scenes to display its own diffs. And this just gives us a different output. If we look at man diff again, and we go down to -u, output the num lines of unified context. So it gives us some context around each change. So let's do that again. Instead of -y, -u. And what we see here are the files that we're comparing, and then context. This is saying from line 1 to 6, we can see what was added or removed. And then same thing here, we can see what was added. So this is maybe familiar if you use Git, and that's the basics of the diff command. Next up, we'll talk about the find command. So find helps you find files or folders, matching some file pattern, but there's quite a bit to it. And we could have a 20-minute video at least devoted just to the find command. So I'm going to just try and hit the highlights here. The first thing you should know is that we can find files and folders by a bunch of different criteria. We can find based off of, let's open up the man page, based off of the name of the file, the modification time, the file size, the type, if it's a file or a directory or a symlink. There are probably many others that I'm forgetting at the moment. And I'm just scrolling through the man page here. It's quite long, as you can see. So again, we're just going to hit the some of the highlights here. Okay, so the first thing is if we want to find files or directories, we need to provide a location to look inside of. So find inside of, in this case, dot, meaning the current folder, or find in the desktop, or find in my animals folder. And then we provide some sort of criteria, something to search against. In this case, -name, and then some sort of name that we want to find. So I'm just going to search on my desktop. I have a bunch of files, but find will search recursively. So if I do a find dot and nothing else, just find dot, it is going to find every single file nested somewhere inside my desktop. So there's a lot of stuff going on here. If I scroll, I mean, you can see they're all nested. They're not actually on the desktop. They're nested multiple levels deep. We didn't specify any way of narrowing what we're looking for. But now let's find everything that has in its name, and then instead of quotes, let's search for anything that has, how about the number 7 in it? Anywhere on my desktop, or any folders nested in the desktop, or folders nested in those folders, and so on. Really? Nothing. Why didn't we find anything? Aren't there, at least there's one file here that has a 7 in its name? And the answer here is that it's looking for an exact match. A file that has, and it is called 7. If I made a file called 7 right here, and I reran it, it would work. We found that file. But what I want to do is find any file on my desktop or nested somewhere on the desktop that has the number 7 in it. So this is where the special wildcard characters of a star, in our case, will come in. A star is just going to refer to anything, and then a 7, and then anything else, optionally before or after. So if I do this, we now get a bunch of matches, a lot of Pokemon that I have for a different video I made, that have a 7 in their name somewhere. But I'm sure there's some non-Pokemon. Here we go. Morning Day 27, nested very deep inside of this folder. Or here's, file 257. So we found files that contain 7 in their name. So if I wanted to find all files of a particular type, like all Python files .py, I would put a star, which again means anything, followed by .py. And it looks like there's just one. Let's try a .js. We've got a couple of JS files nested in my desktop. Now remember, dot is where I'm searching inside of, and that's just my current location. But I could instead say, I want you to search only within the stuff folder, if I can spell it correctly. It's not going to find anything, but maybe I'll find txt files. And there we go. We only find txt files inside of stuff. So we can also find by type. I can find directories or files or symlinks. So why don't I do a find on my desktop once again, and all that I want here are any entries, anything that it finds where type is D for directory. Now I forgot to specify where to search. We'll search in our current directory, and I get a list. These are all directories. There's a lot here, but no files. If you notice, none of the actual files are present. No .txt or .js or whatever. It's just the directories. If I did type F, I only get the files. As you can see here, these are all, of course, they don't have extensions, so you can't tell, but you'll have to trust me. They are all files for each Pokemon in this case, or whatever you're seeing printed out. These are all files. There are no directories that have been found. Now, there's directories referenced in the path to each file, but that's not the same thing as the actual directories being returned as a result here. So we can combine them too. Maybe I want to find directories only. So I'm going to do -type is D, and name has, I don't know, how about an uppercase E? We'll see if we find anything that contains an uppercase E, and we do. So only directories somewhere on the desktop where in their name they have an uppercase E. So here we go. Uppercase E, these are all directories. Now, I can also do a case insensitive version. If I do iname for insensitive, now I'm finding everything that has an E. It doesn't actually matter if it's uppercase or lowercase. So we see things like right there. There's an E in that directory's name. There's an uppercase E and a lowercase e. Okay. We can also do fancy logical things like use the OR operator, so -OR. So let's give it a shot. Let's find anything that has in its name, so in our current location, -name, it starts with the letter E. So actually, sure, let's do E. So E and then followed by anything. Now remember, if we put a star there, that means anything can come before the E. But what I want is it must begin with the letter, in this case, uppercase E. So we get a bunch of the E Pokemon, and there's some others, Edgar, Ethel, Elvis, instead of the chickens directory. Now, if I also wanted to say, or name starts with, how about F, star. And now I have fall, fungus, as well as Espeon, and files and directories that start with an F or an E. Uppercase only, because I didn't do iname. So that's just a taste of using the OR operator. There's also a NOT operator. We can do things like search by file size, how many bytes, how many megabytes, greater than something. So for example, to find files that are larger than 100 kilobytes, but smaller than 1 megabyte, we could run this right here. So find where type is file, F, and size is plus 100K, greater than 100K, and size is minus 1 megabyte. So let's try an example. Let's do find where type is file and size is greater than 100 kilobytes. And there we are. We get a list of files that are greater than 100 kilobytes. If I left that size off, we get way more files. We can also do things around time. So if we want to find files that were edited more than 3 days ago, we would do -m time, which is modified time, plus 3. And then we get to the last little bit that I'm going to mention around find, which is this weird looking thing, -exec. This is an option we can provide where we then specify a command that we want find to run on each found result. So this example is going to find all files in the current directory, right? Type is file. And on each one, it is going to cat that file out. It prints its contents. Now, I'm not going to run that because on my desktop, I've got a million files that it will print out. But let's talk about this quickly. So -exec is just the option saying, hey, I'm going to give you a command I want you to run with each match. And then here's the command, the entire command we're providing. We do have to terminate it with this backslash and then a semicolon. That is how the terminal knows where that command ends. And then this, the curly braces, opening and closing, is going to be replaced. It's a placeholder. It will be replaced with each found result. So let's try an example. Let me recall this line where we found files that were larger than 100 kilobytes. Well, we could verify the size of files one way at least is with -l, ls-l rather, right? And we can see the file size here. And there's a lot of them. There's a couple that are larger, but most of them are pretty small. -l is going to give us that long listing. So what I want to try is taking these files that we find that are larger than 100 kilobytes and then telling find to then call ls-l and then curly braces. And then we need our backslash semicolon. And of course, my font is quite large here. But what you can see is that for each one of those results, if I just run find without -exec, these are the results, right? I think that's greatgatsby.txt, Pokemon exercise, nano exercise, whatever these different files are, they're all here. But we actually executed ls-l with each one, and we can see that file size is large, much larger than the other ones. We could do something instead, like if we wanted to, cat each file out. But again, there's going to be quite a few things printed out. So all files larger than 100 kilobytes, -exec means I want you to then run each match with cat curly braces. So just concatenate them all. Oh my goodness. That's a lot of stuff that was just printed out. A lot of it is kind of messed up, but there we are. That is the result of executing that cat command with every single one of the found files that matched with our find command. All right, so there's a lot more to find. You can do some really powerful things, but that's just a quick intro. Next up, another command that could have its own video for 20, 30 minutes at least, grep. There are many articles, many tutorials that are quite long that exist solely to explain all the different options and various ways of using grep. So what it does is it helps us find text inside of files. So the find command helps us find files, right, based off of their file name or different attributes, but it's not searching in the files. Grep will search inside of files. So the simplest way to use it is to run grep and then tell it some string or some piece of text or something that we're trying to find, and then a file to search inside of. So let me show you an example here. Let's clear this screen, all this craziness. I have this Song of Myself file. Here I opened it in less. There's a lot of stuff in here. And I want to find every time this file, I don't know, mentions green in it. So I can do grep, green, songofmyself.txt. And it prints out to me the matches, right? It highlights them in a different color of every time in this file the word green showed up. So we've got green leaves, green and violet, dusky green, pale green eggs, quintillions green. There we go. We can also ask grep to give us the line numbers with the -n option. So we'll add that in right there, -n. And now I'm getting the line numbers. So 32 is the first one all the way to line 1026. I can also ask for some context. If I use an uppercase C, and then I provide an argument, a number of lines I want, in this case 2, that will give me 2 lines before and 2 lines after each match. So let's try that. C, and then 2. And here we go. So this is one match. This is actually the last match on this line. We have 2 lines before and 2 lines after. Here's another match, right? We have 2 lines after, 2 lines before. Another option we can pass to grep is -r, which is for recursive. And this is a bit different. This will actually tell grep, if I do grep -r, and then provide some pattern like chicken, it's going to tell it to search recursively, in my case right now, just in the current directory and all nested subdirectories. So instead of just looking inside of one file like hello.txt, which doesn't exist, now I can look inside of all files. At least if I tell it a starting point, I think the default is just dot. Okay, so what we see here is a bunch of matches, one from gg.txt, or a couple from sorted everything and everything, feedstore.txt, website.html, greatgatsby.txt. So these are all files that were nested somewhere in my desktop, and they all contained chicken. Now, it is important to note that it is case sensitive. So if I did, uppercase C, no matches, but I can make it case insensitive with -i, and now I get my matches again. Now, what makes grep really powerful is that it can work with regular expressions, which I'm not going to go over right now. If you know about regular expressions, you know the syntax, you can provide regex patterns to grep to search against. So you could find all matches of an email pattern or a phone number pattern and that sort of thing. Okay, well, I changed my mind. I'm going to show a quick example. I'm not going to explain any of it because regular expressions is its own crazy topic. But what I'm doing here is using a pattern. This is a regex that will match email addresses. So I'm searching across recursively, across, in my case, the home directory, tilde, for any matches to this email pattern. All right, so I didn't type this out myself. Just to be clear, I found an email regex, but I'm going to run it, and you'll see a bunch of different emails that have been matched. Bing@search.mozilla.org, toolkit@mozilla.org, toolkit@mozilla again, Firefox. These are all coming from some documentation, it looks like, from Firefox. Here's some other ones. Anyway, the point is, we can match these patterns across in a file or across our entire machine. And there are tons of powerful regular expressions that you can write. But we're not going to talk about how that works. It's a whole separate topic. Anyway, that's a quick intro to grep. Next up, DU, disk utility. I think that's what it stands for. I guess I should verify. That would be the logical thing it stands for. Well, disk usage. No, I'm totally wrong. I'm pretty sure it's disk usage. Anyway, what we can do with DU is find the sizes of files and directories on our machine. So if I just run DU in my current directory, wherever I am, it's going to give me an output of all the other directories in here and their sizes. So you can see, if I just pick one of these, let's find something slightly larger here. Sure. This tar demo folder is 32 kilobytes. This wildlife folder is 16. This cleanup directory is 156 kilobytes, and so on. And then down at the very bottom, I can see my actual current folder right here is dots, is 36 megabytes. I can provide a folder to look inside of instead of just my current directory. I could say, I want to know the Pokemon exercise folder. What's its size? And it's, 24K. We can tell it to give us a different format, megabytes or gigabytes, using -G for gigs, -M for megabytes. So let's do DU, we'll do everything here, -M for megabytes. It's all just 1, maybe 2. But if I do it on my Mac here, we may get some more stuff. not a whole lot, but some of this stuff, here's something 410 megabytes. Here's something that's 25. Now, you may notice it's not actually giving me the unit. It's just 1 or 0 or 10. If I use -H, which is for human readable, it now is giving me a human readable size. So 4K, 24K, but then also for some of these larger things, we get, gigs, 5.7 gigs. So this is what I use most of the time if I actually need to read something as a human, -H. Now, here's kind of a nifty thing we can do. If I want to find the largest directories on my desktop here, I can do du-h for human readable. Okay. And I can pipe that to the sort command. Now, we're almost there. It is sorting, but the way that it's sorting is not exactly correct. If you notice here, it's doing a sort, once again, based off of the digits. So it's saying, 9.2 M megabytes is somehow smaller than 900 kilobytes. So it's putting all the nines together. That's a start, but it's not actually sorting them. So sort actually gives us an option. If I go to man sort, it gives us an option -H. Oh, where'd you go? I lost it. Here it is. Human numeric sort. So it sorts by numerical value, but it takes into account prefixes or suffixes like K or M or G. So it's for human readable numbers. So let's run this again. We are going to get a human readable format from DU of all the files on my desktop, sort them with -H to make it a human readable sort instead of the default sort. And now, if we go to the top, we get our smallest files, the kilobytes, and down at the bottom, we get our largest files. And if I wanted to find the top 10 largest files, for example, I could then pipe that to tail. That would be one option. And there we go. I'm getting the 10 in this case, because that's the default for tail, largest. Or I could reverse with -R and instead get the head, which will be the same thing, right? I'm now getting the sort is in reverse order, and I'm taking the first 10 instead of the last 10. Anyway, that's an intro to the du command. The next command we'll see, a nice and quick one, is df, not to be confused with du. The du command showed us file sizes and folder sizes, whereas the df command will tell us information about the mounted file systems, how much space they take up and how much free space they have left. So I'll just show you very quickly here. If I run df with no arguments or options, I'm going to see some output here. Yours will look different. The file system, so each individual file system, and then the amount of size that it has been allocated, how much it uses, how much is available. Now this by default on Ubuntu is in 1 kilobyte blocks. It's not so easy to read. If I switch over and use the -H option for human readable, now we get megabytes and kilobytes and gigs and that sort of thing. Okay, so we can see things like here is this file system udev. Here's where it's mounted. Here's how large, how much space it's been allocated and how much it's using. I'll show you this on my Mac as well. So let's do that now. I had to zoom out quite a bit just so that we can see the columns. But what we'll see here is that some file system has been allocated up to 3.6. This is actually tebibytes, not terabytes. It's a 1.1 times, so 10% larger than a terabyte. And it really doesn't matter. The thing is, I know this is a 4 terabyte computer, the drive here, so 3.6 terabytes makes sense. Anyway, that's how much space it's been allocated, but it's only using, this file system at least, is only using 10 gigs. Or, here's another one. This is my /dev/disk 1s2, blah, 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 blah. And here's where it's mounted. It's also has up to 3.6 terabytes to use, but actually it's used 2.2 terabytes out of that. Anyway, you may not really need to use this command, but I'm just being comprehensive here. One thing that can be nice, though, is if we pass a file or a folder as an argument to df, it will tell us more information about the file system that particular file or folder lives on. So if I wanted to know, where's my desktop and how much space is that file system taking up, I can do let me just clear first. I can do df-h for human readable and then desktop. And we can see this is the file system. This is, the capacity of that file system, how much is available, and so on. So that's all there is to df. And remember, du tells us about the actual sizes of individual files and directories. df tells us about, I don't know if it's disk free or disk file systems, or I don't know what the F stands for. I was trying to look at the man pages and figure it out, but think of it as disk free, sure. Next up, the history command. Now this one can be very useful, especially if you have some long commands you ran, 20 or 500 commands ago, and you want to rerun it and not have to type it yourself again, or you don't know what it was. That is what the history command helps us with. So on its own, if we just run history, let's do it here on my Linux machine. So I'm going to run history here. I'm going to get a bunch of lines. As you can see, there's a number next to each, and then a command that I ran. So we can see a history of all the commands that I've run. So history was the most recent command. Before that, I had man, df, and then du-m. I had clear. I had du, all these different commands. And let's say this is the command I want to rerun. This is the grep that will search for regular expressions. It searches for emails using an email regular expression across my entire machine. I don't want to have to type this myself. One option, I guess, is just to copy and paste that, definitely. But there's also something called history expansion, where if I have that number, and your numbers are going to be different, but if I have a number, I can take it and simply run exclamation points and then that number, 2064. And now it's running that command. Again, it's finding all these matching emails across my machine. So just one more example. Oh, geez, I need to rerun history. And if you prefer, you can actually pipe this to less. So that command less opens up a program where we can scroll a bit easier. We can page through commands one at a time. I can find some command like, this one here, that finds things that start with the letter E or F. So it's 2040. I can exit less and just run exclamation point 2040. And now it finds me all the files and directories that have an E or an F, uppercase, as their first letter. Another thing you can do is actually combine grep with history. If you're trying to find some command you ran a long time ago, as you probably just saw, there's tons of commands here, and somewhere in this massive list, my history list, there was a command I ran, and I know that it included the word, cookie, but I'm not sure where it is, and I want to rerun that. Well, I can run history and then pipe that to grep. Remember pipe, that pipe character allows us to take the output of one command and pass it as input to another. So then I can search for cookie. And there's quite a few, actually, surprisingly, where there are commands. So we're just searching through the text returned from history using grep. We found a match, 6, 7 different matches. And if I want to run one of these, I can take that number and exclamation point, that number. So 1686, this is just going to make me a bunch of files. Do I even want to do that? Not really, but I've already committed. Okay, so you can see it made me those files. I think it was cake and cookie, and there's cookie. Cake is up here somewhere. Anyway, that can be quite useful. If you know somewhere in this massive history, there was some command and it included some pattern or some word, and that's all you remember. Well, you can use grep to search for it. The next command we'll cover is ps. So ps is a command that helps us inspect or view the processes running on our computer. So if we take a look at man ps, process status is what it stands for. Didn't actually know that. I just always thought of process in my head. Anyway, it's going to display information about currently running processes. And by default, if we just run ps, I'm on my Mac in this example, with no other options or arguments, it shows me a list of all the processes started by me, the current user. So what we see here, we've got, first of all, the process ID, we've got the time, we've got the actual command. You can see I've got a bunch of bash shells, and then really the only somewhat interesting thing, I guess, would be this Python process I have. I have a Python server in a different tab that I've started, but just to show an example, I'm going to start a Node server in this tab. I've got this app.js. I'm going to run it with Node. Here's my server. It's running. I started a new process. Now if I run PS again, we see somewhere, there we are, that process right there. Okay, so that is a process I started, and we can see it right in this list. It has an ID, and in a moment we'll also learn how we can kill a process where that ID can come in handy. But there's more to this command. We can also view a list of processes initiated by anyone on our machine, basically all the processes, not just the ones that are user initiated by me. So all processes. To do that, PSAX. So this is a pretty common one, PSAX. We're going to see a lot more going on here. So we still have, that Node server I started up. We've got our bash instances, and then a whole bunch of system stuff. Look at all these processes. Now, you will see they get cut off here. So they don't wrap over to the next line. I can't scroll. It just gets cut off. So there's a way around that. It's a very weird option if we add on two W's, AXWW. Now, you'll see that they wrap around. So I've got my short processes that I initiated here, but then some of these are quite long, like this Google Chrome helper renderer. I mean, it goes all the way down to about there, I think. No, actually here. I mean, that's very long, but it does wrap over instead of being cut off. So something that can be very helpful is to combine grep with the PS command so that you can find some process. And generally, when you're trying to find a process, at least when I'm trying to find something, I actually might be trying to kill it, which is, again, a command we'll learn shortly. So there's this massive list, and somewhere in here, I do think I have Visual Studio Code open, but I don't know what its process ID is. That's this first column here. I could search, though, so I can recall that command, and then pipe it to grep, and let's just look for visual to start. All right, well, there's quite a few of those. How about Visual Studio? Okay, so here are all the matches for the Visual Studio Code processes. Quite a few still. Wow. All right, didn't narrow it down all that much. But here, this is the one we'd probably want to kill, the Visual Studio Code.app. Now, I wouldn't actually kill Visual Studio Code this way. You can just quit it or force quit it. But when I cover kill, just in a moment, you'll see that there are some situations where you would need to do this. You actually would need to find out the process ID. All right, so that's a quick intro to PS. There's a lot more to it. As you can see, there's some options. We didn't really cover any of these. You can filter processes by who they belong to or who started them. You can change the display format. You can add more information to be displayed. Anyway, there's a lot more you can do. But the basic concept is that it displays information about the processes running on your machine. The next command we'll take a look at is top, T-O-P. I actually don't know what that stands for. Does it tell us? Not really. It just says display and update sorted information about processes. I think it comes from the fact that it will show us the top most memory intensive processes or the top most CPU intensive processes. So what it does, if we just run top, it's going to open up sort of a different screen. We don't see our prompt anymore. What we see now is a little dashboard that shows us information by default of the top, that must be where it comes from, the top most CPU intensive processes. So you can see over here the command. So I've got ScreenFlow. That's what I'm using to record this video. I've got some core audio, terminal, the top command itself. They each have a process ID. We can see a bunch of other information, the memory that they're taking up, the CPU percentage, and we can also sort instead by memory. So if I rerun this, it's -O-M-E-M for memory. And you'll see now this is highlighted, and we can see they are sorted in order of how much memory these processes take up. Processes. So Chrome, unsurprisingly, is up top. And then I've got, these are, I'm using parallels for my virtual machines. I have Windows running over here, and then I've got Linux running over here. So that's what you see there. I've got Chrome again, PDF editor, the ScreenFlow. Anyway, it doesn't really matter, but what you'll see is different. But we can sort things by the amount of memory they take up, and we can see that process ID, which is useful when we want to kill something later on. You need to reference that process ID. All right, so that's top. To get out of here, type Q. That's the easiest way. I think you can also get out with Control C, most likely. Yeah, I just use Q. The next command we'll cover is kill, K-I-L-L. We use this command to kill programs, but it's actually a little bit more complicated than that. It's not just a matter of saying, shut this thing down or kill it. There are a whole bunch of different types of signals that we can send when we run the kill program. So there's actually a lot of different signals, and it can be very overwhelming and confusing if you try and understand them all. I'll just quickly show you here. If we run the kill command with -L, it's not going to kill anything. It instead will list the different signals that we can send. So there's things, actually, to make this a bit easier, why don't we pipe that to less so I can scroll through it. All right, so we've got things like SIGINT and SIGIL and SIGKILL, SIGBUS, SIGTERM. SIGTERM is actually a pretty common one. It's terminate. We've got SIGKILL, signal kill. Let's see, there's a whole bunch of these. The vast majority I've never ever had to use. And they all are supposed to be different. They all are supposed to do different things. But what's confusing is that it's actually up to the specific program that you're trying to kill. It's up to that program's source code to handle these different signals. Okay, so let's talk about some of the most common signals and the basic syntax. Essentially, the way that we kill something is by using the process ID. We saw how we can use commands like ps and top to find a process ID. And then we specify a signal. So we can specify a signal using the long form, a word. So HUP, that's a common one, means hang up. We can send, term to terminate. That's the default. But what I prefer to do, and what a lot of people do, is instead you can use a number. So as we saw here, there's a number corresponding to each one of these signals. So if I go back, as I said, term is a common one. The number there is 15. Kill is 9. So we could send that signal too. All right. So if you're wondering, what does this all mean? When would I use one versus the other? The way that I think about it is that in general, I try and use 15 first. This is the gentlest way to quit something or to stop a process. Think about, with the graphical user interface, the different ways of quitting or of shutting something down. One option is to just quit your application and save your changes. Another is to quit and click Don't Save. Another option is to force quit the entire application. Another option is to unplug your computer. These all are different ways of quitting or shutting down a piece of software. And that's kind of a silly version, but the idea is that there are these different signals. So 15 or SIGTERM is a gentler way to quit. It basically, the idea is that your program that you're quitting or killing would have time to tie up any loose ends, save any necessary state. Whereas on the complete other end of the spectrum, we have 9, which is what a lot of people use. So a lot of the tutorials and docs you'll see just says to use 9, which is the most brutal way of just shutting everything down and basically just force quitting a program. And then there's a whole bunch of stuff in between. But I like to try and start with 15. That allows things to shut down how they would normally. And if that doesn't work, then we use 9, which is just pulling the plug on the life support for that program. All right, so let's see how it works. So just like a burgeoning serial killer, we need to find our first thing to kill. So fortunately, I have a couple of node processes that I want to stop, I want to kill. If I do PSA here, I have a server running. 2 actual node servers. Here's the process ID. We'll just take that first one. And I want to kill it. So I'm going to copy that ID. And it turns out that, I can't stop this any other way. Normally you start a server and then you can stop it with Control C or something, but I've lost that window. I don't have access to just type Control C to quit the server. So I need to kill it this way. Okay, so I have the process ID. Now the syntax is kill, and then I can provide either a number, like if I'm doing 9, that is the brutal way of killing something. That's the just immediately kill. We can provide the name, kill, or even the full name, sig kill. But I'm going to start with the default. So if I just kill, and then I put the process ID in there, this will send a terminate signal. That's the gentler way first. That's the default. So this is a gentle way that gives it time to close up shop and save its state if needed. So if I try that, I don't get any feedback. And if I do PSA again, it's still there. So it didn't seem like it worked. Just give it a couple of seconds. Sometimes we'll just double check, come back. Nope, it's not working. So now it's time for more aggressive action. We're going to provide a signal. And remember, we can list all those signals. If I do kill-L, this isn't that helpful, to be honest. It gives us a list, but what does this mean? What I generally stick with, and by far the most common, if you are going to pass one through, is 9. But remember, that's the brutal one. 9 is the kill signal, and that's the one that just pulls the plug. So we can pass that in. Kill, let me just clear, -9. And why didn't I just show you? It is here, right? There's that process. Kill -9. And then the process ID. Okay, once again, no feedback whatsoever. PSA, and now it's gone. Now we just have this other node server running. Okay, so that's the basics of the kill command. I know it can be a little overwhelming, but the idea is that you provide some signal and then a process ID, and that signal will be sent to some, usually kill or terminate or do something to end that process. Next up in our killing arsenal is the kill all command. So kill all is different from the kill command in that we actually can provide a name. Instead of a process ID, we can provide the name of a program that we want to kill. And if we have multiple, it will kill them all. So if I just happen to have multiple node servers running once again, I actually just have them here. So here's one, and here's the other. I could just, Control C and quit them nice and easy, but let's just say I can't. So I want to kill both of them. Instead of doing the process IDs and all of this, I can just do kill all, and then provide a signal just like before with regular kill. I can do kill or sig kill or 9, and this is the most violent way of killing something. Kill all -9 and then node. So that is the name of the program I want to kill. Once again, no feedback, unfortunately, but let's see what happens. Well, I don't see any node processes here, and if I go to my terminal windows, killed and killed. So that is the basic use of the kill all command. It doesn't require a process ID. It's definitely less precise. Generally, I use kill because I can isolate exactly what I want to kill. But if I know there's multiple things, or it's a pain to find the process ID, then you can use kill all. Next up, we're going to talk about 3 commands that go together. Jobs, JOBS, BG for background, and FG for foreground. So these 3 work in conjunction, and they all have to do with running things in the background and, in the foreground. So if we have some command or a program that happens to take a long time, for example, a command like this where I'm using find in the root directory, so on the entire machine, find all files that have changed in the last 1 day, 24 hours. So there's a lot of system files and a whole bunch of stuff. It's going to take a long time. If I just run it right now, I'm going to get a bunch of permission issues, but it's still running. If you look down here, it's going, and it's going to take quite a while to check every single file on my machine. So it's running in the foreground right now, right? Meaning I can interact with it. It's not, happening in the background. So I can stop it, right? If I do Control C, that just stops the whole thing. And there's actually something else I can do. If I run Control Z, what I can do is suspend it, which kind of puts it in a state of, suspension. It's not stopping it entirely forever. It's not ending it. It's pausing it. So I'm going to rerun that. And by the way, what I'm doing here is finding all those files and then putting it all eventually in a file called all changes, or maybe I should rename that to be all changed files or whatever. We're not going to be using this to do anything. I just am using it to illustrate that we can have these things that take forever. So if I hit Control Z, right now, you'll see it says stops right here. So this is slightly different than what happened earlier. And now if I type the jobs command, which is how we can check up on any jobs we have running, we see this program is currently stopped. Okay, so let's try doing something else. What about the top command? If you remember, this is going to show me all these different processes on my machine and how much memory and all this stuff that they're taking up. And I can use Control Z to stop this as well. So Control C just gets me out of there. If I do Control Z, it actually stops that or pauses it. And if I type the jobs command again, now we have 2 jobs in here. So 2 different jobs that are both Control Z'd. They're both suspended. Now, what I can do is selectively rerun or resume one or both of these jobs in the foreground, like what we saw here, it was in the foreground, or I can actually run them in the background so that they keep going, but I won't see all this text. I won't see them in my terminal, but they'll still be running. So this jobs command is just how we check up on jobs, see what their state is, and they also have an ID or a job number, and that's important because when we want to selectively resume them, we can use those numbers. All right. So the first command I'm going to show you after jobs is actually FG for foreground. So if we run foreground and then we specify a number, a job number, that job will be resumed. So if I want to resume the top command, its number is 2. So if I do FG2, there we go. It is now running again and it's in the foreground. So I could suspend it with Control Z, or I can just get out of here, Control C or Q. If I look at jobs now, we just have this one job, right? This is my find program. Now I can resume this in the foreground by doing FG and then the number 1, or because it's the only job, I could just type FG. So I'm going to do that now. And here we are, it's resumed again in the foreground. It's just going to take forever, and maybe we'll get some permission denied stuff. Let's see if there's any text. And if I grow tired of this, I want it to run in the background. I don't want to see all of this taking up my terminal screen. I want it in the background, not the foreground. I can suspend it and go back to jobs. It's suspended. I can resume it, but instead of doing foreground 1, I can do background 1. Whoops. And that will resume it. It will be running, but I'm not going to see it running. So I'm going to do that. So it gives me a little message saying, all right, this is running, and it's in the background. And the way that we know it's in the background, there's 2 ways. 1, this ampersand means something is running in the background. 2, if I type jobs, it's telling me right here, running. So it is running, but we don't see it running, right? We don't see all that text. But by using the jobs command, we can verify it is indeed running. I could bring it back to the foreground if I wanted to. Foreground, I don't have to specify 1. It's the only job. And here it is. It's in the foreground. And that's really all that there is to this. We can run things in the foreground, in the background, and we can use the jobs command to check up on them. This is going to just take forever. Let's see if it ever finished. I'm just going to quit or stop it. Let's look at our all changes file. Yep, so it's got a lot of stuff in there. And let me just prove this to you one more time that it does work. So I'm going to remove that all changes file. Yep. All right, so now we no longer have that all changes file. If you remember, I said the ampersand is one way we can send a job to the background. So here's another very stupid program in this context. Sleep is just going to stop. If I just run sleep 5, I'll just show you the man page. This is a new command. It just delays for a number of seconds. So 5 seconds. I won't do that long. Let's do sleep 2 seconds. So you'll see nothing happens. It's a delay for 2 seconds, and then my prompt comes back. So we can use this if we're writing a script or something where we need to stop to wait for data to come back, or to wait for to make a user feel like something is taking longer than it actually is for better UI. There's all these different uses, but typically I don't run sleep unless I'm teaching it. Now, I can run this in the background. So let's do a long sleep, like 50 seconds. So if I ran this in the foreground, again, it's stupid to do this, but if I did, I'm waiting here for 50 seconds, and I can't do anything else. So I'm going to Control C and end that. But if I run it in the background, which I can do by just adding an ampersand, so sleep for 50 seconds in the background, that's what the ampersand at the end means. Now, I don't see that happening here. If I look at jobs, it is running though. It is a job, it's running in the background. And then I could bring it back to the foreground if I wanted to, just like that. And now it's running in the foreground. All right, so I'm just gonna stop it anyway. And if I go back to jobs, now there's no jobs. All right, so that's kind of a lot of stuff around jobs and foreground and background. Let's just recap that. So if you have a program, you run a command, put an ampersand at the end, it's going to run in the background. If we don't do that, but we want it to run in the background, say after the fact, let's rerun my find command, this long find command. I could run it and then suspend it and then decide I want that to run in the background. So I could get the job ID. I happen to know there's only one job, but I could get that ID and now say, go in the background, 1. And now it's running in the background. And it will take a while. Eventually it will complete. It's still running. As we can see here, it has that ampersand. It shows us it's happening in the background. I don't know how long it's going to take. Quite a long time. But eventually it will finish. Next up, we're going to talk about compressing files. We'll first talk about the gzip command, which is used to compress files. It uses an algorithm called gzip. There are multiple different compression algorithms. If we take a look at gzip on the man pages, the whole idea is that it reduces the size of files using Lempel-Ziv coding, LZ77. So, compressing is a very complicated, interesting, but very complicated area of study, and there are quite a few different algorithms, but one of the most common, on Linux at least, is gzip. So the way that it works is that we have some file, hopefully a larger file that we're trying to reduce the size of, and we provide it to gzip. However, I would warn you, it's not a huge deal, but if you just run gzip with a file name, it is going to take that original file, compress it, and replace the original file. So you'll only have the compressed version that ends in .gz. That's just the extension that it gives it. If you want to keep the original file, you can do two different things. This is a slightly clunkier way, but the better option, in my opinion, is to use -k. I don't know if it stands for -keep. That's what I think in my head. And that will keep the original file. So let me just demonstrate this here. I've got a somewhat large text file. If I just cat it out, there's a lot of stuff in there. It's the result of running a find command and redirecting the output into this file. Okay, so if I run gzip and I'll do -k on that file, we don't get any output, which I'll show you how to correct in just a moment if you want some output. But if I type ls, we now have this file here, all changes.txt, so the same name, but now it has an additional .gzip extension. If I do an ls-l, we can see the file size difference, but actually let's make it human readable with LH for human readable. Pretty significant reduction in size, almost 2 megabytes down to 200 kilobytes. Now I'm going to remove that. So remove all changes.txt, and I'm going to just show one more oh no, I removed the wrong thing. Well, that's annoying. All right, it's gone. I don't have that original file. If you remember when I talked about remove, when you remove, it doesn't go to a temporary recycling bin. It is gone. But the good news is we do have the zipped file, the gzip compressed version, and I can unzip that to get my file back. So we'll just jump ahead and talk about unzipping. So the way that we can do that is to use the -d option to decompress. That is one way of doing it. And then there's also a totally separate command called gunzip, which you can use, which is basically the exact same thing. There's a couple more options, but it will unzip a gzip compressed file in the same way that gzip-d will unzip. So let's start with, why don't we do gunzip, all changes.txt.gz. All right, I type ls, and there we are. I now have the uncompressed, if we do ls-l, let's do lh, 1.8 megabyte version. Okay, so let me just show one more thing. When we gzip it again, so I have that original, I want to keep the original. And if I add -v for verbose, it's going to give me information about how much space it reduced or how much it compressed the file. All right, so I'm going to do gzip-kv, and then my file is allchanges.txt, and it says it reduced it by almost 87%. If we do lh for ls, we can see, once again, 1.8 M, 232K, so a lot smaller. And then, just one more time, we can use gunzip, or we can do gzip-d for decompress on that file. And it's going to ask me if I want to overwrite, because what I'm doing here, right, I kept the original, so I would be unzipping a new file with the exact same name. Do I want to replace it? Sure. Okay. And now we're back to what we were at before. It is, well, let's do H again, 1.8 megabytes. So I unzipped, and that's kind of all that there is to that. One thing that's important to know about gzip is that it will only zip individual files. So it won't take 10 files and zip them together into a single compressed file. We'll see how to do that with a different command. But just to show you what happens, if I make, let's see, I have this one file. Let's make another file, whoops, just with some very small text in there. I'll call this 1.txt. And let's do it again, actually, for 2.txt. Okay, so I now have 3 files in here. If I do gzip, and I'll do -k, if I want to keep the originals, sure. Gzip-k, and then we'll do v as well for verbose, all changes, and then a space, 1, and 2, I can provide multiple files, and it does compress them, but it compresses them individually. So we end up with 3 different gzip files. Okay, so it did not combine them, it just compressed multiple. So that brings us to our next command, tar, T-A-R. Tar is a command that we use to create an archive, which is basically a grouping of a bunch of files, potentially a bunch of files, together into a single file. And then we can go and compress that file. So the name tar is short, I think, for tape archive, an older relic of days gone by. But anyway, the way that it works is it's kind of complicated. There's a lot of options. The man page, if I just go to man tar, is very long, lots of options. But I'm just going to show you some of the most basic things that you might want to do. Primarily, taking a folder full of a bunch of files and combining them down into a archive, and then compressing that, so that we have a single file that is compressed that we can then unzip later and then expand back into a whole bunch of files. Okay, so the syntax, the basic syntax, is to run tar, and then a couple of options to create a new archive, to smush files together. We provide the different files we want to smush together, separated by spaces. We provide 2 options, C for create, and then F is the way we provide the file name that we want it to create. So if we provide F, we must provide the archive name. Unlike when we zip a single file, it can, gzip can just use the name of that file and append gz, but here we're combining files together. So we need to provide an end result name. Okay, so I have a simple, whoops, let me go into that folder, a simple folder here. ls-lh shows us we got 3 files, lots of text, more text, and songofmyself.txt. I'm going to combine the 3 of these into a new archive. So the way that I do that is tar-c for create. F is the file option, so I provide the file name for the archive. I'm going to call it, archive. Okay. And conventionally, these end with .tar as the extension. And then we'll just provide the file. So song of myself, lots of text, more text, and then I'll hit enter. And this will create a new archive file, as you can see right there. And this does not mean it's compressed, to be clear. Okay, it's just a single file. If we look at the file size, it's 3.6 megabytes. Well, we had 1.8, 1.8, and then 85 kilobytes. So we did not lose any size along the way. This is not compressed. But now I could go and compress this if I wanted to. But before we do that, let me show you how we can unarchive. To extract files from an archive, we use the -x option for extract. C was to create, X is for extract, and if we just do XF, and then we need to provide the file name once again, this would be the archive we just created. This will unarchive it in our current folder, but we can also move them, so we can provide a directory, a destination, with -C. And before that, we can actually just view what's in the file if we use the -T option. So I can just show you that. Why don't I move my archive somewhere else? Let's move, why don't I just make a new directory? I'll just call this somewhere. And then I'll move my archive into somewhere. Okay, so let's CD into somewhere. All right, so now I can show that -T option, which we can use to view the files that are inside of this archive. So we have this. Let's just say I downloaded it. I don't know what's in it. Well, I can do a tar-tf archive. And there we go. It says, hey, there's 3 files in here. I don't have them. They're not out of that archive. They're still in there, all combined down into a single file. But I can then extract them. I'll just do it in the current directory. So to do that, it is tar-xf and then the archive. And now I have those 3 files, as you can see here. Okay, and then again, I could provide a destination instead if I want to extract them somewhere else with -C. Okay, so still no compression. The next step is to combine compression, gzip is going to be our algorithm, along with archiving with tar. So we can do this separately, just to be clear. I could do, if I just remove lots of text, more text, and Song of Myself. Yes, yes, yes. Okay. So I have this empty directory except for the tar. I can compress that tar as we saw with gzip. So gzip, and then I'll do -K to keep the original file if I want to, archive.tar, and now I have the compressed version. Okay, so it's only 502 kilobytes compared to 3.6 megabytes. So let's delete the original tar. So rm archive.tar. And now I just have the compressed archive. So this is really, a bunch of files combined down into a single archive, then compressed. This might be something we download or something we get from some mysterious source. Now I want to get it back to the original files that are inside of it. So I need to uncompress, and then I need to unarchive. So to uncompress or decompress, remember, we use gzip, and then -D, and then the name of the file. So now I just have the regular archive. It's much larger, right? 3.6 megabytes. Now I need to unarchive. So we need tar-x for extract, F, so we provide the file, which is archive.tar. And there we are. We get our original stuff back out. Okay. So you can do it in 2 different steps like we did there. Make the archive, then compress, and then uncompress, go in the other direction, uncompress, and then unarchive. Or we can actually use just the tar command to do it all together. The tar command has a special option Z for gzip, which will also compress an archive with that gzip algorithm at the same time. So instead of 2 separate steps, we can do it at once. So I'll just show that real quick. Let's do the same thing. Let's remove my archive. I have my 3 files. I'm going to combine them together with tar. I'm going to do create. I'm going to zip with gzip. And then I'm going to do F so I can provide the file name. We'll call this bundle this time. tar and then space the files I want. Okay. And take a look at what we get. I should have probably named it with a .gz extension, but if we look at the bundle.tar, it is compressed. It's much smaller. So you don't have to have that extension, but you want that there if somebody else sees it, so they know, this is a gzip file, and you need to use gunzip to unzip it. So if I want to remove these files, so we just have the single archive, or the bundle file. Okay. There we are. And now to unzip it and unarchive, I can just run our regular old tar-x for extract, F, provide the file name. I don't even have to tell it to use gunzip. So let's try it. There it is. Remember, it looks like this, 500 kilobytes, single file. I'm going to do a tar-extract, and the file name is bundle.tar, and let's see what we get. There we are. We got the 3 files back out. All right, so we saw 2 ways of doing it. First, we can create a bundle or create a tarball and then compress that. Or we can do it all in one go. If we have multiple files we want to combine and compress, we can provide the -z option, as we saw here, to create a gzip compressed file. Next up, we'll talk about a fun command called nano, N-A-N-O. Nano is actually a text editor you can run directly from your terminal. Now, there are other text editors, some that are quite a bit more powerful than Nano, but they are also quite a bit more complicated to learn, and when you're starting out, you can really mess things up. So things like Vim, if you've ever heard of Vim, powerful, but really tricky to learn when you're starting out, and also could have its own hour-long video. There actually are courses on just using it. So we're not going to go into that, but Nano is another editor that comes built in that we can use. And the reason it's good to know one of these editors at least, and there are others, there's Emacs, and the reason it's good to know them is that you can directly, very quickly change files or make modifications, add things onto files without having to go through the whole process of opening up an external graphical editor. You can do things quickly. So I don't use something like Nano as my main editor. I like using VS Code or something similar, but it doesn't mean you shouldn't know how to use it. Now, the basic usage is nano followed by some file name we want to edit. So what do we have here? I've got songofmyself.txt. I'm going to open that up with nano. So this is a file we've been using quite a bit throughout the course. And when I hit enter, you'll see that my prompt goes away. I'm now in an editor. I can use the arrow keys to move, and I can actually immediately start editing. And this is different. If you ever have encountered Vim, if you start typing, you're not actually going to be editing things immediately. There's all these different modes, and you might be messing things up significantly. But I can start typing. So if I want, I can say, hello there. And I can use my arrow keys left and right, just like a regular cursor, up and down. And let's just start with that. I'll make a little change there. All right, so I've made this change. Now I want to save this. This is probably the most important part of working with Nano. It's down at the very bottom. Down here is kind of a little toolbar. This is a list of shortcuts, the different commands we can use inside of Nano. And one of the most important ones is this right here, Control X. This is how we can exit. So if I do Control X right now, first it's going to ask me, before you go, do you want to save or not? I'll save that change, so I'll hit Y. If I don't want to save it, I'll type N. And if I don't want to quit, I can do Control C. Okay, so I'm going to hit Y to save. And then it's going to ask me, well, do you want to keep the same file name? Do you want to make a new file name? Save it somewhere else? I'm just going to hit Enter and keep the original file. So I'm just saving a new version of Song of Myself instead of a copy. All right, so it's still there. And how do I take a look at the beginning of the file? I just want to see if it changed. Head, Song of Myself. There it is. We did successfully make a change. Now there's more that we can do. So I'm going to reopen that file in Nano. And a couple of things. First of all, if you notice on the right side here, I'm getting a little angle bracket, greater than sign. That is telling us that there's more text. So you can actually turn word wrapping on or line wrapping if you prefer for it to wrap over. But I think the default is for it to just scroll, as you see there. We have different shortcuts down here. So if we wanted to search, for example, to find something in this file, I can do Control W. All right, so Control W, and then I can provide something I want to look for. So I want to change the word green in this file. So I'm going to type green, and I'll hit Enter. And my cursor shows up right there on the first match of green. Now I could keep searching again if I do Control W and hit Enter again. See, it already remembers green. It takes me to the next match. So let's just make this all caps and very long green. All right, I'll save. And as we saw previously, one way of doing that is by quitting, and it will prompt me, do you want to save, blah, blah, blah. But if I don't want to quit and I just want to save my changes, I actually do have Control S. So I just did it. It doesn't show up down here, But there's far more options that don't show up down here. I'll show you how to view them in a moment. But Control S does save to the current file, right? It's not making a new file name. It doesn't give you an option. Do you want to save this somewhere else? It just saves to the same name. Okay, so if I type Control G right here, get help. I wish it was Control H. Control G is harder to remember. We get a whole manual here that explains how it works and then explains all the different shortcuts. So there's quite a few things in here. We saw Control W to search forward. We can actually insert another file into this file or into this buffer with Control R. We can cut and paste. So this is one that you've probably noticed. Control C and Control V for copy and paste don't really work in the terminal. Control C has its own meaning, just like Control Z has its own meaning to suspend a job. Anyway, we still can cut and paste. The way that we can do it is with Control K to cut. It actually stands for kill, and then U to revive or to unkill. I don't know what the U stands for. And that will basically take whatever we've cut out and paste it. So I can show you that. There's options to configure a spell checker. We can display line numbers. We can go to a particular line number if we know what we want with, where's that? Control underscore. There's a bunch more stuff. So, this is not a course on Nano, but just so you know, there's a lot to Nano. Okay, so to get out of here, Control X is going to close the help screen. Now, as I said, I want to show you cutting and pasting. So if I want to cut a line, I guess maybe I'll just type a line first. Hi there. Cut me out of here, please. All right, if I do Control K, it's gone. And then I can move it down somewhere, maybe here, and Control U, it revives it. And I keep hitting Control U. There we go. It's just like cut and paste. If you do forget about that, we can see shortcuts down here. Okay, so I'm going to save, Control S. We also can do Control O to write out. If I wanted to create a copy or a different file name, I could type that here. So maybe, Song of Myself 2.txt, and this is my version. I'll hit enter. Do I want to save it under a different name? Sure. And then I'll get out of here, Control X. One more thing I'll show you. You can actually create a new file with Nano. So if I need to add some text into something, a file that doesn't exist, I don't have to make the empty file first, then open it with Nano. I can just do nano new file.txt. And now I have an empty file. I can type my stuff in here, save, and quit. Control S, Control X. And there it is. Song of Myself 2 from the previous Nano. And then new file.txt. Okay. Next up, we have the alias command. The alias command allows us to define our own aliases, our own little short custom commands that we can then reuse later on. So, for example, if we find ourselves doing, ls, remember, just gives us this information. ls-a gives us all, including hidden files. ls-la gives us listed long format information for all files. If we find ourselves doing that a lot, we could set up our own alias so that we don't have to type all of that and maybe just have LA, for example. So if we wanted to do that, I want LA to actually be ls-la. The way that we do that is by using the alias command. So I'll show an example here. I'm going to do alias, and then let's just call this I'm going to do something really obvious first, like my ls equals, and then in quotes, I'm going to use single quotes. There is a distinction here. Single quotes, and then I'll do ls-la, just like that. Okay. So if I type alias now, I'm going to see a list of all my aliases. I actually have quite a few on here. Here's the one I just made already. And if I try running it, my ls, there we go. I have a new alias. I could take something, really long, like if there's some find command that I use a lot. Let me just show an example here. I think I have, like this one right here. This finds some of I think it's the top 10 most CPU intensive processes on my machine. honestly, I never use it because I don't even remember this. But if I run that, it's a very long command, relatively long. I can alias it to something short. So pscpu10. And there we are. I need to sort of zoom out. My font size is too large for me to make sense of this here. But that's all right. I'm recording. I need that large font size. The alias we just defined is not permanent. If I close this window or even just open another window, my ls, it's not working. It doesn't know what the heck I'm talking about. So when I just define an alias like Bobo right here equals, I don't know, how about just sleep for 10 seconds? Okay. When I define that in my shell directly here, it only exists in this exact instance right here. It is not going to be created every time I open up a new terminal window or my computer restarts. I lose it. So if I want to make an alias last, if I want to have it persist, I need to put it in one of a couple different places. It depends on what shell you're using. If you're using bash, if you're using Z shell, there are different configuration files. Now, over here, I'm using bash. This is Ubuntu. The default shell is bash. And if I go to my home directory, it's actually where I am right now. Again, home meaning my home folder, not the folder actually called home. It's confusing, but my user's home folder, Colt. If I do ls-a, there's some of these special config files. Now, there's actually on Ubuntu, there's one called bash aliases, and that is a good place to put aliases. However, that is particular to some distributions of Linux. It is not something that you may not see it depending on what distro you're using. So a safe place is going to be the bash rc file. So it's hidden, .bashrc, and I can open it up. I'll use nano to edit it, .bashrc. Okay, now I'm in nano, I can scroll down, and I can define my own aliases in here. So let's just, I think I already have some here. There we are. So I'll just define some in here, just as an example. Alias, and I'm just going to write the exact same thing that I wrote earlier, except I'm putting it in this file. And what's special about this file is that when the shell loads up, it will run this file, and it will run these aliases first, before I even have a chance to do anything else. In other words, it will know about all these aliases I define. So let's see, what should we do in here? I'll make an alias called count. Okay, and count is going to echo. And if you remember our expansion, I'll just echo 1 to 99. I don't know why we would do this, but sure, we will. And then I'm going to save this file. So this is nano. The easiest way is just Control S. And then I'm going to exit with Control X. Okay, so can I run count? No, I can't run count just yet. I could open up a new window and it will run that bashrc file. And now if I try running count, hey, it works. Alternatively, if I don't want to do that, I can actually source, the command is called source, my bashrc file. And now I can run count in this same window. Now, if you're on a Mac, the default shell is Z shell, as we discussed earlier. You could switch over to bash if you wanted to, and just type bash, and now I'm using bash, and I can define my files, or rather, I can define my aliases inside of my, let's do ls-a here, lots of hidden files, inside of my bash profile here. That's where I could do it on a Mac, or more likely, if you're using Z shell, which is the default shell, the file we want to add our alias to is .zshrc. Where are you? ZSHRC, right there. So that is our configuration file for Z shell. So I can do nano.zshrc and scroll down. I don't have to scroll down. I can define my aliases anywhere in here, but somewhere in here I can define an alias. So let's do a different version of count. These are how we write comments, by the way. So if you want to have a little note, or you want to have something not take effect, you can put a octothorpe or a hash sign in front of it. So alias, let's call this one, let's do, I'll just do another, count, count again. But this time on my Mac, count is going to be an echo about 1 to 365. Sure. All right. And that's it. We could also define, L, a more useful one. How about LL, which will be ls-l. And how about we'll do LA, will be ls-la. So now, and actually, why don't I do one more? Why don't I alias rm to instead be rm-verbose? So it tells me when it deletes something. So I have that over on my Ubuntu over here, which you may have noticed. So let's just define those four. We have count, ll, la, and rm. I redefined the rm command to actually be rm-v, so that -verbose option is always there. I'll save and exit. Yes, I'll save. Okay. So in a new window, I can run my count command. I have the ll command. I have la, which also does hidden files. As we can see, my hidden files are showing up. And then I did the rm command. So let's just create a file called remove me and delete me. Now, if I run rm on remove me and delete me, oh, well, I didn't fully expand delete into delete me, but still, it shows me what it removed. So let's try one more time there. Let's rm delete me. There we go. And now it just tells me, it gives me a bit of feedback as to what was deleted. Anyway, that's the basics of using the alias command. Remember where you define those aliases. First of all, if you don't define them in a file, one of these special files, they will not persist, which is fine. Sometimes you may not need them to. But if you do define them and you want them to continue to exist every time you have a new terminal window, make sure you put them in the appropriate file, depending on whether you're in you're using Z shell or bash or some other shell. They all have their own config files. And one last note about working with aliases, and specifically with quotes. There's a difference in bash between single quotes and double quotes. When we have double quotes and we have a variable, or some form of, so remember there's this variable expansion where we have a $. If I echo some $, and then a variable like path, or there's a user, the shell sees this and it expands that, or it replaces it with the actual value for user, Colt, and that is what is echoed out. Okay, so if I defined an alias that I just wanted to, I don't know, how about, well, let's just use this example here, that is going to ls the contents of our current directory. If I do ls $pwd, that's what both of these are. One has double quotes, one has single quotes. The difference is that whenever we use double quotes, that variable is going to be resolved. The value will be set in stone at the definition time when we actually run this originally. So whatever that PWD value is originally, it will always be that. But if I use single quotes instead, single quotes will be resolved, or that variable will be resolved whenever we invoke this alias. So this, in other words, will be dependent on when I run this. It's not going to be the same thing every time. Versus this one here, because I use double quotes, it's always going to be whatever the value is. I'll just show you here. If I just paste this into my shell, currently the value of pwd, it's my current directory. So if I do ls this, it's printing the contents of my home directory. But if I go somewhere else, like my desktop, and I rerun that, it's still printing the contents of my home directory. No matter where I am, it doesn't matter that I'm on the desktop, or if I go into, I don't know, this wildlife folder, and I run ls this, because I use double quotes, when I defined that alias, this was set in stone at that moment I defined it. Now, if I instead did this, so I'll copy that, and I'll put this in here, alias ls current, it is exactly the same inside the quotes. Remember, if I just echo pwd, it's a variable, and it's just the exact same thing I see if I type pwd. But the difference now is that this is going to rerun every single time that I run ls current. So if I go to my home directory and I run ls current, it shows me the contents of my actual current directory. It doesn't matter where I was when I defined this. So that's an important distinction when we use double and single quotes. Next up, we get to talk about one of my favorite commands. It's not my favorite because I use it very much. That'd probably have to be I don't know, cd or ls or something like that. You just can't get around to using those all the time. But this command, xargs, I don't use very much at all, but when I do use it, it really comes in handy. It's pretty nifty. So here's the whole point of it. Xargs exists to take output from one command and turn it into arguments for a second command. So we've seen how we can take something like, well, first I'll just show you this folder I have. I've got some files, player 2, 3, 4, 5, 6, all the way up to player 9 or player 10. So we've seen how we can do things like take ls and then pass that to sort, for example, right? And what's happening here is that the output of ls is being passed as the input to the sort command. However, when I say input, I'm actually referring to something called standard input, somewhat of a long explanation to really go into, but the idea is that unlike other commands we've seen, like when we touch and make files, I'll make another file here, player11.txt and player12.txt. These are arguments being passed to the touch command. It's a list of values separated by spaces. So when I run that, we end up creating, 2 new files, and they're in here. But when we do ls pipe sort, we are not passing arguments to sort, and this is what's kind of confusing. The sort command is set up to accept values through standard input, and it's also set up to be able to sort things as arguments. So if I provided a file, like I have this file called dead players, we'll talk about that in a moment, it can sort the contents of that file as well. So this is passing an argument versus this right here, we're passing the output of ls to the standard input of sort. Anyway, I say all of this because only certain commands are set up to work with pipes. Only certain commands like sort, and there's a lot of other ones, that will accept an input through standard input rather than through arguments. But there are many that don't. So for example, touch is actually one I just showed you. I can't take the output of one command and pass it to touch, at least not without xargs. So let me show what I'm talking about. I'm going to show you first what we can't do, the problem that xargs solves. So I have some files here, player 1 through player 12. These represent players in some game, and people die after each round of the game, and we need to clear them out. We need to get rid of the players that died. So I have another file called dead players. If I just cat it out here, you can see it has the names or the files of the players who are dead. So what I want to do is take this file, whatever's in it, and delete or remove those files from the actual folder. Now this could be, hundreds and hundreds of dead players, and we could have thousands. I actually recorded this once where I did have thousands. Like when I say once, I mean like 10 minutes ago. I had thousands of players, and then I removed half of them, but I realized that the scale was too large. You really couldn't tell how many were removed. So I scaled it down. We're dealing with 12 now, and we're going to delete, 5 of them here. So aside from me manually doing RM, player 1, and so on, the idea is that this could scale up. We could have thousands of players, and there's some list. We don't even know, exactly what's in there, but some list of dead players. It could be hundreds. What I want to do is take whatever's in that file and dynamically remove those files. So whatever those names are. What I can't do, unfortunately, is just read the file. So we can cat it. And then pipe it to RM. That will not work because the RM command is one of those commands that is expecting a space-separated list of arguments. It is not expecting anything to be passed to it via standard input. So that's what's happening here with this pipe. It takes the output of cat and pipes it over to RM, but RM is not set up to handle that. So just complains. It says, hey, you didn't pass anything in. There's no argument, so what do you want me to RM? Just like if I had run RM here. This is where xargs comes in. The xargs command will take, or it will accept standard input, which is what's coming in here from this pipe. So cat, the output is passed to the standard in of RM, but RM doesn't want anything to do with it. But if we instead do xargs, if I can spell it, RM, what it does is it's kind of like an adapter. It will take that standard in and then turn it into a list of arguments that will work for RM. So this is the syntax. xargs, and then the command that you want xargs to provide the arguments to. All right, so we're going to take this list of dead players, which when we cat that out, it's basically going to take this and provide it to xargs. Xargs then says, okay, let me turn that into a list of arguments that will work for RM, provide that to RM. And now, when I run it, well, we see we lost a lot of players. They're now gone, right? This could scale up again to be hundreds at one time. We can take the contents. This is a simple example. Take the contents of one file and then do something with those contents. In this case, we removed files that had those names. Let's take a look at one more example. What I want to do is run the find command just on my desktop in all nested folders and files to find, how about files that are larger, so size is plus 1 M, so greater than 1 megabyte. And this is what it finds for me. Okay, but I want more information about these. I actually want to then do ls-l, right? So we get that long listing format, but I want ls-l only for these files, which is, 7 or so files. So if I try and pipe it to ls-l, well, surprise, surprise, ls is not set up to accept values through standard input, which is what the pipe does. It is expecting us to provide arguments, sure, after the fact, so we could do, files that end in .txt, but that has nothing to do with our find command. I want to take the results of the find command and then pass those to ls-l in a format that it will accept. So this is again where xargs comes in. So this is the list of files that are greater than 1 megabyte. And then I can do xargs, and then ls-l, that's the command I want to run. And here we are. We now see, let's actually do LH, so I can get the human readable format for the sizes. Not very large files on here, 1.8, 1.8 megabytes, 1.2, 1.2. But these are all the files that we found from that find command. Those values were then passed to xargs. Xargs stepped in and turned it into a acceptable list of arguments that was then provided to ls-lh. And that's how we see this output. So there's actually quite a bit more to xargs. I'm not going to go into here. You can read the man pages. It's pretty powerful, the different ways you can construct the list of arguments, the different separators and delimiters, and you can have it replace different things for you along the way. You can limit the number of arguments. It's quite complicated, but what I just showed you are some of the more common, simple ways of using it, and that's the core purpose of xargs, is to take standard input and turn it into a list of arguments that other commands will accept. All right, so next up we're going to talk about the ln command, which is used to create links. ln link. Now when I say link, it's not a hyperlink or something from a browser. A link in Linux is, or it may be, a new concept to you. It's kind of similar to the idea of a shortcut, your desktop shortcuts on a Windows operating system, where you have some applications that are installed somewhere else. It is not on your desktop. They're installed completely in a different area, but you have access to start them up. You can reference them through the icons on your desktop. So there's a link. Those icons, the little picture of whatever, Adobe Photoshop, that icon on my desktop, when I double click it, it is linked. It's referencing some actual program that it starts up. So the concept is similar. We can have a file that is linked that points to another file. So there are two types of links, hard links and soft links. We'll start by covering hard links, which actually are not used as frequently. But the idea is when we create a hard link, we are creating basically a file that will stay in sync with another file. Now, we're not creating a copy. We're not duplicating a file. It's different. They are pointing to the same thing, the same exact file. So they're not diverging. They're not copies. It's not like using the cp command. That's important to understand. So let me show you an example. We'll start nice and simple. I've got an empty folder. I'm going to echo I am original into a file called original.txt. All right, so I just made this new file. We can cat it out, and it says I am original, and that's the only file in here. Now the syntax to make a hard link is ln, and then the original file, which happens to be called original, and then whatever our destination, or not destination, but whatever the name of the link file that we want to create is, I'm going to call mine hardlink.txt. So if I type ls, we have two files now, or what appears to be two files. This hardlink file, if I cat it out, says I am original. It has the same contents. Remember though, it is not a copy. It is pointing to the same file as this right here. So if I change original, let's echo, this is more stuff. We'll append that into original. So if we cat out original, we see 2 lines now. And if I cat out the hard link, we also see 2 lines. And this goes both directions because they're both referring to the exact same thing. If I change hard link, change from hard link, and I echo that into the hard link file, which is a hard link to that original file, this is what it looks like now. And if I cat the original, it also has that change. So they are 2 things, 2 arrows pointing to that same file in memory. And this means if I were to delete, first, if I delete the hard link, the original file is still there, it's unchanged. But if I delete the original file, my hard link file will persist. It is pointing to that same thing in memory. And that's what's a little bit confusing here. It is not pointing to this name, original.txt. It's pointing to, it's called an inode. It doesn't really matter, but it's referring to the same thing in memory, just 2 different names for it. So if I remove original, I'll remove it, it's gone, but our hard link file, that is still there, that hard link we created, and it still has those contents inside. So that's a hard link. As I mentioned, it's not as commonly used. Then we have soft links. And soft links are different. The first thing you should know is that to make one, we use the -s option. If you just take a look at man-ln and then scroll down somewhere on here, here we are, -s for symbolic. It will make a symbolic link, soft link, instead of a hard link. So what I'm going to do here is remove my hard link. And I'm going to create a new original file. So we'll echo I am original again into original.txt. Oh, I did .tt, but that's fine. Just a quick quiz. How would I rename that without moving it anywhere? Easiest way is just move command. Original.txt is the destination. And there we go. Okay, so I'm going to make a soft link. And to do that, it's ln-s, the file that I'm linking to, and then the new soft link, or the sim link, symbolic link, I'm going to just call symlink.txt. Okay, so what I have now is a symbolic link or a soft link, and if I type ls, you'll see if you have colors enabled, it really depends on the terminal you're using, your operating system, your shell, but for most terminals, there'll probably be a difference, and for me, it's bolded, and it is in a different color, it's cyan. It doesn't matter what color it is, and even if there's no color difference, it doesn't matter. If we do ls-l, we can see a difference as well. If you notice here, here's my original file, here's the symlink file. It has this little arrow pointing to that original file. Additionally, over here, we haven't really talked about permissions yet, but there's a difference. There's a dash here as the first digit, and there's an L here as the first digit. This tells us that it is a symbolic link. It's a link. Anyway, just like before, if I change the original file, let's do a echo, change to original, and then we will append that to the original file. It now looks like this. And if I echo, or rather cat, the symlink file, it also prints out the exact same thing. Now, what if I try and change this symlink file? Echo change to symlink. And I append that to the symlink file. All right, let's see, did that change the symlink? And does that mean the original has changed? Yeah, it goes both ways in this sense. However, where there's a big difference is if I delete the original file, so I have both of them here right now. If I remove original, yes, now we have this symlink.txt, but it doesn't look very happy. It's still there, but it's showing up in red all of a sudden. And if I try and cat the contents, it says no such file or directory. So it's this link that it's just pointing to something that doesn't even exist anymore. So that's the main difference. The symbolic link was pointing to original.txt, and when original is gone, that link is severed. With a hard link is pointing to, don't think of it as pointing to the file itself, but think of the hard link and original.txt as two different pointers to the same thing in memory. So if I delete the original, it's all right. We still have the hard link. It's pointing to that same thing in memory. But here with a symlink, I delete the original. Well, now this symlink has nothing to link to, and it still is there, right? We still see something show up, but it's just completely dead inside. Now you might be wondering, why would you ever do this? Why does it matter? And this is one of the harder things to explain or to convince you of when you're a beginner. And I honestly don't even use symlinks all that much, or any links. Although I end up working with people who do use them, and so I need to be familiar and comfortable working with them. It's pretty straightforward once you get used to just that -s, ln-s. But let me show you an example. If you have Python installed, for me, I have Python, I think it came pre-installed in Ubuntu, and I have a couple different versions. I'm going to run an ls-l on this directory, user bin, and then Python. I'll come back to in a moment, but user bin is where binaries are installed, and so it's where Python binaries will live by default. And there's a lot in here. So first of all, if I just get rid of this Python thing, there's a lot of different programs in here. One of which I'm just going to focus on for now is Python. So if I do an ls-l user/bin, and then anything that starts with Python, maybe I'll even do Python 3, because I have Python 2 and 3. What we see here, let me clear everything else again and just focus on this. What you'll see is that there's 4 matches. There's user bin Python 3.8, 3-futurize, Python 3-pasteurize, and then there's this right here. What is that? That is a symlink. And that symlink is just called Python 3, but it's pointing to a specific version. So when I run Python 3, that's the command I'm running. When I run that right here, it's actually a symlink, and it's referring right now to 3.8. But this allows me to manage different versions. I could then have 3.9 or Python versions that don't exist yet, or older versions, 3.5. I can have them all installed. And then whatever this symlink, it's like a shortcut, whatever Python 3 is referring to is what version of Python will run. So I can have all those versions installed, but only one that is actually run when I call Python 3. So one with this little shortcut. And I run Python 3, and there we go. It doesn't matter if you know Python or not. And we have the same thing. If I just do Python star, Python 2, I only have one version installed, but I have a symlink. And I don't set this up myself, to be clear. This was just done for me when I installed Python. But Python 2 symlink is referring to, there's a little arrow, Python 2.7. But I could also have 2.8 and 2.5. And then switch versions. And when I switch versions, Python 2 will point to one of those versions. So that's just a simple example, but there are many ways you can use symlinks. For now, though, I just want you to understand that ln is a command, and that there are 2 different types of links we can make. We can make a hard link and a soft link, also known as a sim or symbolic link. All right, the next couple of commands we'll learn have to do with users and permissions. They're pretty important ones that may not come up all the time, but when they do come up, they are really, really useful. So on Linux, we can have multiple users logged in at the same time. Doesn't really happen for me. I'm kind of just working on my own on this one machine. And for most people, I shouldn't say most, but I imagine for a lot of you who are watching this video, you may be the only person using your machine. But it's important to understand that you can have multiple users all logged in simultaneously to your same machine. It might be hard to do, right? You may not have the multiple screens and keyboards and whatever needed to have different people logged in at the same time, although it can also be accomplished virtually. The point is, it's possible. There is a command called who, not to be confused with who am I. Who am I tells us the username based on the current effective user ID. For me, that's ColdSteel here on my Mac. Who is going to tell us about the users who are logged in. And like I said, for me, it's really just me. But what we'll actually see if I type it on my Mac is currently seven different, if you include this one, 8, but right here what we're seeing are 7 different users. It's the same user, but they're each added here separately for each time I access or each time I log in via a terminal. Basically, every terminal window counts as a user accessing. So I have 7 right now. This is TTY, it's teletype, I believe. It's an old relic, but anyway, if I create a new terminal window, just ignore it, and then run who again, we now see we've got a 4, which wasn't there before. You may not see that, but if I zoom way in, it says last login on TTYS 004. So, yep, that's why we're seeing all of those there. Anyway, not the most useful command, certainly not right now, and not for me because I'm the only user. But if we're an administrator and we've got a whole bunch of people on a machine at once, this could be pretty critical to know who is currently logged in. Next up, we'll cover the SU command, which is short for switch user. This command allows us to switch users, to log in as someone else within a terminal shell. So you may have situations where you might need to do this. Maybe not. It really depends on what you're working on and how your machine is set up. But if you are an administrator, for example, and you need to do something on somebody else's account, well, all you need to do is run the SU command followed by some username. Now, I have a different user on this machine. So remember, I'm Colt on this Ubuntu distribution here right now. That's who I'm logged in as. But I have a user called Elvis. And when I do SU Elvis, it asks me to enter Elvis's password. So I can't just switch users to be whoever I want without knowing passwords, unless I'm a root user, unless I have full permissions, but I don't. So I switch user to Elvis. I need to know Elvis's password, and I'm pretty sure I just got it wrong. I did this last night. Let's see. There we go. Entered the correct password, and you'll see my prompt changes. It now says Elvis at my Ubuntu, and if I type who am I, it now says you're Elvis. But just to be very clear, this is in one window. Over here, I'm still Colt. So I haven't completely logged out and become Elvis everywhere. It's still my horribly messy desktop, but I am Elvis in this tab. Aside from what we see when I run who am I, if I cd to my home directory, well, my home directory tilde, if I do pwd, is home/Elvis. Whereas over here, I cd to tilde, and I do pwd, home/Colt is my home directory. So as Elvis, I can do things like, well, there's nothing in this home directory, but I could make a file, touch from elvis.txt, and I have permission to do that. But if I go back and I go into Colt's account, or rather Colt's home folder, remember I'm logged in as Elvis here, not Colt. What happens if I try and make a file here called from elvis.txt? I can't do that. So I'm logged in as Elvis, but that doesn't mean I can do everything Colt can do. We have different permissions, and that's something we're going to start to try and understand. We'll walk through how permissions work. But this is just a quick introduction to the concept that different users have different permissions. They can do different things. And if I went the other direction as Colt, I can make a folder or a file from Colt here, no problem. But if I back out and I try and go into Elvis's directory, I can do that. But if I try and make a file, touch from colt.txt, no luck. I can't do that. I don't have permission. Anyway, that's the basic idea of using SU. You probably wouldn't do this, just make a random folder or file in somebody else's home directory. But if you do need to switch users, that's how you do it. You need to enter the password, and then to get out of here, I think you can type exit. Also, you can just do Control D or Control C, I believe. Now, there's another option when we run SU. If I do man SU, there's this dash that we can provide. And if you provide that dash, let's see if I can find it here, it will start the shell as a login shell with an environment similar to a real login. This means it clears all the environment variables, it initializes the environment variables home, shell, user, log name, and path, and it changes us over to the target user's home directory. So remember, when I logged in as Elvis, I was actually just in Colt's home directory anyway. It didn't take me to Elvis's directory like a normal login would. But if I instead do su dash and then Elvis, I can also do -L, but it's so common that you can just do dash. It's a very short option. I'll type Elvis's password, and it takes me right to Elvis's home directory. This acts as a real login shell. And then to get out of here, again, I can type exit, or it is Control-D, I believe. There we go. Okay, so that is su to switch users. Next up, we'll talk about the sudo command, sudo, which is short for super user do. And the command allows us to run commands, other commands, as the root user or with elevated permissions. So there's this concept of the root user, a user in Linux who basically has permission to do anything, to create new users, to change passwords, to remove files and folders. And we actually, if I just run ls-l here, I'm logged in as Colt. What we see here in this third column is the owner of particular files and folders. But if I keep backing out, now we see, my different users. If I take a look at one of them, like Kitty owns these files and folders in his or her desktop, or home folder rather. But if I back out another level, so here I am one more time, now we see a bunch of these really important directories who owns the bin folder, where I have things like, if we just cd in there, all our programs are installed. Who's in charge of that? Which user? Well, if I type ls-l, we see root all over the place. The root user is in charge, or not in charge, but the root user is the owner of these programs, these files and folders. And that's just one example of, the significance of root. Root can do all sorts of things. Like I said, a root user can change someone else's password. But as Colt, just a regular old user, I can't do that. Now, there's something very important to know. On Ubuntu, at least, in many Linux distributions, the root user account is actually locked. It's not accessible. You can't log into it. There's no password. I can't just log out and log back in as root. If I go to log out, we will see. Yes, I'll log out. We saw the text root all over the place in my terminal, but there is no root account that I can actually log in as. So why is this? Well, it's just how Ubuntu is set up. It was a decision that was made. Rather than having a single root account with a single password that you can log in as, instead, individual users, I have 4 here, Colt, Kitty, Carrot, and Elvis, individual users may be able to run commands as the root user, and that's where this sudo command comes in. So how does this work? It's not like it's a free-for-all, and every single user on a machine can run commands as the root user. Those permissions are actually listed out in a particular file. There's a lot that goes into it in managing those permissions. What I'm just going to show you, though, is that when you create your initial user account, so Colt was my initial user account. Whoops. I'm logged in now as Colt, and I'm looking at my settings. I can see different users. Again, none of them are called root, but some of them, including Colt, which was the first account I made, by default is an administrator. So that means I can add and remove other users. I can change settings for all users, but that's not the same as being the root user. And then some other users, Carrot, Elvis, are not administrators. Kitty is an administrator. When you make a new user, you can decide that. Now that's just one basic difference, or one basic toggle between permissions, but we can get very detailed about who is allowed to do what, but we're not going to go into that. I just wanted to make it clear that this sudo command I'm about to show you is not carte blanche for every user to do everything. So I'll demonstrate that. Okay, so how do we use this sudo command? The idea is that instead of using a single root password, each user has their own password. we enter that password. It's going to prompt us for that password. And then it's going to check, do you even have permission to run this command as root? So it doesn't turn us into the root user. It doesn't give us permissions to do everything if we don't already have them. It only allows us to do certain commands that we are specifically already permitted to do. It's just an extra level of protection, basically. You have to type sudo, you have to type your password. So even if you have those permissions, you can't just normally go around deleting everyone's stuff. You need to run sudo in order to do that. So if I wanted to edit some particular configuration file that affects everyone on a machine, if I just tried to open it in Nano, I'm not going to be able to do that. But if I try using sudo first, I'll enter my password and it will check if I'm allowed to do that or not. So let me show you. Let me get my terminal open. So the file that we're going to look at is in /etc/host. That's the name of the file. And if I just do an ls-l on it, remember this is high up directory. It is not located in Colt's user directory or any other user. It's above. And if I run ls-l, we can see that the owner is the root user. But again, there is actually no way to log in as the root user in Ubuntu. So if I want to edit this file for some reason, I could try running nano. And it does open up. I can actually read the contents, but it tells me, for you, this file is unwritable. So I can't make changes. I'll get out of here. But if I now prefix this with sudo, superuser do this. So superuser do this command. It's first going to say, enter your password for Colt. That's who I currently am. And it's going to check if I have permission, if I am granted those root permissions to edit this particular file. So if I enter my password, this is not the root password. This is Colt's password that I log in with. And we see I actually am able to edit this file. I'm not going to because I really don't want to, but this is a file I can change now. But if I go log in as a different user, and remember we saw how to do this, I can use su-, I have Elvis as a user on this account. I'll type Elvis's password. Okay, who am I? I am Elvis. So if I try and run this nano etc/hosts, I also see, hey, you don't have permission to do that. That's a file owned by root. But if I try sudo, just like I did as Colt, it now asks me for Elvis's password. So what is Elvis's password? Well, I'm not telling you, but I know it. I type it in, and it tells me, nope, that's not going to work. We checked. Elvis is not in the sudoers or sudoers file. We're not going to really go into that, but there's ways of managing who can do what. It's more of an administrative process or a specialty that I'm just not going to go into here. But it's important to note, specific users can have different permissions. Who is allowed to do what as the root user? And Elvis doesn't have any. So I can't edit that file as Elvis. But again, if I switch back to being Colt, I'll just get out of here with exit. And I run that sudo nano blah, blah, blah. I already entered my password, so it remembers it there, just to be clear. But you will need to enter your password when you run sudo, your particular user's password. Now, you've probably actually come across this before when it comes to installing software or installing new commands. There's a command called TLDR. I don't have it installed. And if I try typing it, my shell is going to tell me, I don't know what you're talking about, but here are some things you could try installing. So there's a command called apt install, and then the package TLDR. But if I just run that without sudo, I'm not allowed to do that because I'm installing something that is not even just specific to my user here. It actually is specific, or not specific. It would apply to all users on my machine. I'm actually installing a program, a command that everyone can use. So I can't just go around doing that. I need to have permission. So that's why we run sudo. Do I have permission to install this? Well, I already entered my password again, so it knows who I am and what permissions I have to do as the root user. I can install it, so I will continue. And it will take a little while to install. The point of this is not to show you how to install things, by the way. It's just to show you another situation where you would need to use sudo. So anytime you're trying to make changes, you run into a permission denied error, you'll often be prompted to try it again with sudo first. So sudo itself, we prefix in front of other commands, and then it will prompt us for our password. And now I have this tldr command. Just show it to you on the man page for it. Here we are. Anyway, it really doesn't matter. It was just about using sudo. So it really depends on who you're logged in as and what permissions you specifically have been granted. And that is something that can be tweaked. It can be really down to a pretty granular level. I haven't changed anything. It's just that some users have administrator permissions on here. Some of them don't. Now, not all Linux distributions will have the root account locked, so you can't log into it directly. Some of them you can, but even then, we still have access to the sudo command, and we can grant specific users different privileges as root. It's also, on my Mac, I can run things with sudo, and I often need to if I'm installing something that is system-wide. Same idea. The next command we'll cover is the password command, which is actually passwd. I guess those extra 2 letters are too long. And this is a command we can use to change someone's password. So there's 2 ways of using it. You can change your own password by just typing passwd. So I'm logged in as Colt. I guess I'll change my password and then I'll change it back. So it's going to ask me for my current password. So I have to know that. And then it asks me for my new password. And let's do... I'm not going to tell you. And then I have to confirm it again. Okay, I updated my password, and you can just trust that it worked. How would you really know, I guess? I'm not going to tell you what it was before or now, although none of them are actually real passwords anyway. But it did change, and if I were to log out, I would need to use that new password. So I'm just going to change it back one more time. Current password. Whoops, I messed up. I'm going to do that again. So my current password, I just changed it to. My new one. Okay, now I can also change someone else's password, assuming I have root permissions. So let's say I need to change Elvis's password. He's forgotten it. There's actually a lot you can do. You can lock someone's password. You can, if we just go to man passwd, you can do things like expire an account's password, which would force them to change their password next time they log in, but it doesn't actually give them a new password. You can make an empty password to disable a password for an account. There's a lot here. I'm just going to show the basics. So I want to change Elvis's password, passwd, Elvis. Well, I can't do that, right? As Colt, I need to do it as the root user, or I guess as Elvis. But as the root user, it's probably more likely, right? Why would Elvis need to change his password from my account? So if I have permissions, I'm the administrator. Remember, on Ubuntu, I can't log in as root. So this is the closest thing. I'm an admin. I have permission to do this, but I have to use sudo. So sudo password Elvis is now going to ask me for my password, not Elvis's. It's going to ask me for mine, and it's going to just verify. Are you even allowed to do that as Colt? Okay, now it's asking me for Elvis's new password. So I'm just going to change it to, how about hacked? Okay, and one more time. And now I just changed Elvis's password. I guess, I could show it to you quickly if I do an su Elvis. If I try and use Elvis's old password, which was something involving the word taco, it doesn't work. But now if I log in as Elvis using hacked, it does work. And then as Elvis, I could change my password again using password. And I don't need any fancy permissions. You can change your own password. All right, so that's the basic use of password. It is passwd. There is more to it. As I said, you can lock someone's password. You can delete it. You can expire it and force them to set a new one when they log in. But again, it comes down to you can change your own password, or if you have permission as the root user, you can use sudo in order to change somebody else's password. The next command we'll cover is one of my favorites to say out loud, chown or chown, change ownership. This is the command we can use to change who owns a particular file or directory. So let's talk about what that means to own a file or directory. On every file, every directory, let me just go home here. I'm logged in as Colt. Who am I? When we do ls-l, we see a whole bunch of information. We're going to talk more about what this is in just a little bit, permissions. And then this right here, this third column, is the owner of the entry. So in this case, the owner of this directory files exercise is me, Colt. The owner of music is Colt. This is pretty normal to own all the stuff in your home directory. But if I go to somebody else's directory, if I have multiple users, let's go to Kitty's directory. So this is her home directory. Kitty owns almost all of these files and folders. And if I keep backing out further, we've seen this before, root, the root user, owns all of these directories and files. So the chown command helps us change who owns those files, and that's important to do because the owner of a file is allowed to change its permissions, to delete it, potentially to read or to write to that file. It all has to do with what we see over here, which we will get into in just a little bit. But for now, I just want to show that we can change the owner, and then we'll try to understand its implications later on when we talk about another command. All right, so I'm going to go back home. And the syntax to change the owner looks like this, chown, and then the owner that we want to add as the owner, so a user, and then the file that we're trying to change. So I'm going to go into Elvis's directory, or maybe it doesn't really matter who. I'll go into Kitty's. Kitty. All these files, almost all of them, are owned by Kitty. If I wanted to change the owner of, how about Kitty's music directory, the syntax would be change owner, chown, and then me, Colt, that's the user I'm trying to add as the owner, and then after that, music. Now, there is a bit of a problem. I can't just change somebody else's, I can't just make myself the owner of somebody else's directory all over the place. Like, that is something I have to have permission to do. And we've recently learned that we can use the sudo command to act as the root user. So that is one option here, is if I have root permissions, I can change the owner of any files. Sudo chown Colt music. So it's going to ask me for my password. And then I enter it, and I don't see anything, but that's a good sign. That means that I did have permission to do that. And now you can see Colt is indeed the owner of this music directory. Now, again, we haven't really talked about what that means for me to be the owner, but I'll just show you. For example, if I were to go into the desktop and try and create a file, touch made by Colt, I don't have permission in that directory. But if I go back out and I go into music, if I touch a file, touch made by Colt, I do have permission now because I am the owner. As we saw when I did ls-l, I own that folder music. One commonly used flag with chown is uppercase R, which we can use to recursively change the ownership of all the files and subdirectories nested in a directory. So I have this directory I just made called cat stuff, and it has some files inside of it, and then a nested directory with some other files. And if I decide I want to make the owner of cat stuff Kitty, and this is all kind of silly, and you probably won't just make a directory in your home folder and then make someone else the owner, at least not frequently, but just for demo purposes. If I make Kitty, another user on my computer, if I make her the owner, I can do chown Kitty, and then I need the name of that directory, which is cat stuff, and I do need to use sudo. Even though it's my own folder, that might seem weird, like you should be able to change who owns your own stuff. The way Linux is set up, that is not the case. You still need to have root permissions. Now, you can change the permissions attributes we'll talk about very, very shortly if you are the owner. But you can't change the actual owner of a file unless you have root permissions. And I already typed my password a couple minutes ago or seconds ago, so I don't have to redo it. And if I do ls-l, we see, where are you? Cat stuff, Kitty is the owner. But if we cd into cat stuff, ls-l, I, Colt, still own all the files in the nested directory. So to change that, we can just rerun that line, the chown line, but we use the -uppercase R to recursively change the ownership. And now if I go back into cat stuff, Kitty is indeed the owner of all the nested contents. If we go into toys, Same thing there. Kitty is the owner of those files. Okay. Now another thing you may notice when I run ls-l, let me go to, how about Kitty's home folder. So we'll go /home/kitty. Inside of here, when I do ls-l on any, it doesn't matter where, but in this directory, ls-l, I see a bunch of folders and files. There's an owner that we talked about. That is a single user who is the owner of that file. But then, why does it say Kitty again? Or here it says Pals Forever. What is this second thing? This is known as the group owner. And this is a little confusing, but every file on a Linux system has an owner, and it has a group that owns it. And that group can have multiple users who are members of that group, and then the group can get its own set of permissions. So this means that, I could be the owner of this file, and I might be able to read, write, delete, whatever I want. And then members of the Pals Forever group might be able to read only, but they're not able to edit this file. They're not able to write to it. So this allows us to have two different levels of permissions. The owner can have some set of permissions. What are they allowed to do? And then members of the group that is an owner, the group owner, they also can have a separate set of permissions. And it's all encoded in these weird little digits, RWX and dashes here. We will talk about that very soon. But what I want to show you right now is that we can just change the group that owns a file using chown. Now, this is something you probably won't do very much, and I'm not diving into groups and managing groups and creating new groups and changing members who belongs to a group. That's all more admin stuff anyway, not day-to-day user stuff, at least in my experience and with my students. But it's worth knowing that we can use the chown command to change the group owner. So I have this group called Pals Forever. I can actually, there's a command called groups. I can see all the groups that the current user, belongs to. So here's all the groups. We've got Movie Club, Pals Forever. Let's say I want to change the group that owns music from Kitty, and this is also somewhat confusing. By default, the group is going to be a group with your username. So it says Kitty and Kitty, but this is the group owner. This is the owner. All right. If I want to take this music directory and make Pals Forever the group owner, the syntax looks like this, where we have the owner name, a colon, and then the group that we want to add. So here, if I want to keep the owner as Colt, I need to do sudo chown Colt : Pals Forever, and then music is what I'm trying to change. So this will be the owner, and this is the group owner. ls-l, and if we look at music, that group has changed. Now again, the idea behind groups is that we could have 10 different users who are part of this group, and they might be able to read this directory only. But then the owner can read and write and execute and do everything. So we can have these different levels. So it's not just one person who's allowed to do things with a file. We can selectively change these groups and add people to the groups. But that, again, is a more advanced admin thing we don't really need to worry about. All right, so the next thing we're going to talk about is understanding, when I do ls-l, the very first chunk of really bizarre looking text, these characters here, we want to understand what these are, what they mean, because we're also going to learn a command that allows us to change these. So what we're looking at right here is for every file, every directory, these are the permissions or the file attributes. They detail what the owner is allowed to do. Can you read, write, or execute this file? What the group members, who are part of the group that owns this file, can do, read, write, and execute, and what everyone else can do. Can the world at large, any user, read, write, or execute? So there's a lot to break down. There's actually 10 digits here, or not digits, 10 characters. And the first character, actually I'm using some of my slides I've made for a course on Udemy if you're interested in a lot more of a deep dive into Linux commands, because this is just hard to explain without graphics or some visuals. So anyway, that first letter, it's either going to be a dash, so not a letter, that indicates that it's a file, a plain old regular file. A D indicates a directory, so we can see that already. Here's a file, .txt, it has a dash. That's the first character. Here's a folder, or a directory, it has a D. And then for symlinks, I think if I just back out a little bit here, they'll start with an L. So here's a symlink here. We can see we also have that arrow pointing to, where the link is linking to, and it starts with an L. So that's the first thing. That's kind of just a one-off. Then we have 9 characters, which is actually 3 sets of 3. The first group of 3 tells us the permissions for the owner of the file or directory. The second group tells us the permissions for the group owner or for members in that group. And then finally, the third group tells us the permissions for everyone else, the world at large, any other user that's not the owner or that is not part of the group that owns the file or folder. Now, within each group of 3, we'll just take the first one. So for an owner, those first 3 digits, they tell us the read, write, and execute permissions for this file. Can the owner read, write, or execute? So those 3 characters in a very particular order. The read permission is first, then the write permission, then the execute. And then it starts over. Read, write, execute for the group owner or group members. Read, write, and execute for everyone else. So what do these 3 permissions mean? Well, if we have an R in that first spot, right? Here there's an R, here there's an R, here there's an R. That means that the file can be read if it's a file, or if it's a directory, it means that the contents of that directory can be listed. Okay, so here I have a single file I've created called onlycoltcanread.txt. And we'll learn how you can change these permissions, but I've already changed them. The first thing we see here is a dash. That means that it's a file. Then we have those first 3 digits, which are the owner permissions. Now the owner is Colt. And there's an R present here, which means that I have permission to read. The owner, whoever that is, has permission to read the contents of this file, and I can read it. Okay. Then we have the next 3, which is all just dashes, which means none of those permissions are present. So this is the group permissions. Anyone who's a member of this group, well, they don't have any permissions here. And then everyone else, they also don't have permissions. So that R would be that character right there. There is no R. That means whenever we have a dash, that the file is not readable or executable or writable, depending on the location of where that dash is. So here, if there's a dash, that means the owner couldn't read it. But there is not a dash, there's an R, which means we do have read permissions. So let me demonstrate this. If I switch over, I'm just going to log in as Elvis. If I can remember the password. Uh-oh, that's not it. All right, let's try that again. Oh, wait, I think I changed it to hacked, didn't I? I forgot about that. There we go. All right, so I'm now Elvis. Who am I? If I do an ls-l, well, I'm not Colt. I'm not part of this group. So I'm considered anyone else. I don't have read permissions. There's just a dash there. If I try and cat the file out, permission denied. Only Colt can read that file, or only the owner, which happens to be Colt. Okay, so this pattern holds true for all of these permissions. If there's a dash in any of these spots, it means that that respective, if it's the world, the group, the owner, does not have that permission. So here we can see the owner does not have execute permissions. The group does not have execute permissions. Everyone else does not have write or execute permissions. Now what those mean, we'll dive into, but for reading, as we saw, if there's an R there, that means the file can be read. And if there's an R on a directory, that means that we can list the contents of that directory. So this is why, as Elvis, I can do ls or ls-l or something on this directory. I'm actually going to zoom out further or move back one level. If we look here, this is each user's home folder. So we got Carrot, Colt, Elvis, and Kitty. Each user has RWX, that means read, write, and execute. But then there's an R present for everyone else, for that world, right? Everyone can still read these directories. That doesn't mean I can change them, of course. But this is why, as Elvis, I can go into Colt's directories and list ls-l. I have that permission because I have that R attribute right there in that third set. So remember, first 3, that's going to be the owner. members of the group, and then everyone else. And I currently am part of that everyone else. I'm able to read the contents here, but through some editing magic, I did just change the permissions on the permissions directory here. If you notice now, there is no R present. We'll learn how to change that in a bit. On this third grouping, which means that anyone who is not the owner or part of this group cannot read the contents of this directory. Now, it is a directory. So what does that mean? Remember, the R character means that you can list the contents of a directory if it's a directory, or you can read the contents of a file if it's a file. Well, I'm Elvis still. If I try and ls that permissions folder, I can't. I can ls any of the others. I can ls music. I can ls desktop. But when I try permissions, I can't do that because, once again, we no longer have an R present there. But if I switch back to being Colt, now I'm Colt, we can see I can ls permissions, no problem, because we have an R in that first grouping, which is the owner's permission, so I can read. All right, so that's our first type of permission, read permission. If there's an R present here, here, or here, that means that either the owner, members of the group, or everyone else can read. Next, we have this second slot, which is for write permissions. So a dash means no write permissions. A W means write permissions. So for a file, that means that we can modify the file. And for a directory, this means that the contents can be modified. You could change files. You could make a new file, for example. You could rename. But this actually only takes effect if the executable attribute is also set, which is that third piece here. So let's just focus on files. So if we have a W present, that means we can write to a file. So here we have ilovekitty.txt. The owner is Colt. There's a W there, right? Here's that first group, or I shouldn't say group, but the first chunk, 1, 2, 3, for the owner. I can write to that file. I can echo into it. Let's just do echo meow into I love. No, I need an uppercase L. No problem. I'm Colt. I can do that. If I cat it out, we see it has meow. But now if I switch back to being Elvis, put Elvis's new hacked password in there. I am Elvis here. If I, as Elvis, try and add to that file, if I try and open it with nano, if I try and echo something into it, well, Elvis is not Colt, so these permissions don't apply. I'm not part of that group Parallels, so these don't apply, but it doesn't matter anyway, because it's the same as the permissions for everyone else. What we see here is that everyone has read permissions, but no write permissions. So I cannot write to that file. If I try to echo, I don't know, hi from Elvis into I love Kitty, permission denied. I cannot write to that file. But I can print it out or read the contents because, once again, we have that R right there. So I'm Elvis. That R applies to me. I'm not the owner. I'm not part of this group. We have read, but no write permissions. And then what about this third slot here? So that third slot is either going to be an X or a dash. If it's a dash, it means no execute or executable permissions. If it's an X, that means we do have executable permissions. So what does that mean? Well, it's easier to understand in the context of directories. If we have a directory, you'll see actually there's a lot of X's on directories. By default, everyone has X executable permissions on folders. All that means is that we can cd into a directory. So it doesn't matter who I am right now. Let's take a look at the wildlife directory. There's an X present for the owner, group members, and for everyone else. So I'm currently Elvis. I can cd into wildlife. No problem. I'm in there. Now, if I, behind the scenes, get rid of that X, I'll do it right now. There we go. There is no X there anymore. We're about to see how to do that. I'm going to go back to being Elvis. If I try and cd into wildlife now, cd into wildlife, permission denied. We don't have an X there. And for Elvis, that means he can't execute. He cannot cd into that directory. Now, members of the group, Parallels in this case, anyone who's in that group can. And then the owner, Colt, can cd as well, because that's the owner's execute, the group members execute, and then everyone else's execute. So normally you'll have X present all over the place for directories, but I just removed it here to show you the consequences. I'll go back to being Colt, and I can cd into wildlife, no problem. Now, it's a little trickier to explain what it means when we have a file. For files that have an X present here, so if I were to show you a couple of examples like this right here, these permissions means that an owner has read, write, and execute permissions for this file. No one else has any access whatsoever. What does that X mean on a file? It means that the file can be treated as a program and can be executed. So if you write your own scripts, you write your own programs, and you want them to become executable, you need to have that X there. So we're not going to see that right now, but I'll show you some examples of things that are executables. If we cd back a couple of times, we go into bin, what we see here, if I do an ls-l, are lots of X's present, but these are actually files. So these are programs, as you can see. So there's a lot of programs here. Once again, I'm in slash bin, rather, is my path name right now. Binaries. This is where programs are stored. So if, here's touch, for example. That is a program that I can run. Obviously, we use it all the time. Or if we find, let's see, is there another simple one in here? Here we go. Here is echo. So our echo program that we run, that command, it's defined right here. It's a file. It has some code in there. And as you see, it's X, X, X. That means we can execute it as a program. We can actually run it. Okay, so what I want to demonstrate is a little odd, but there's a program called ncal. It gives us a calendar. I'm going to make it so I can't actually execute that, and then I'm going to undo it. But I'm not going to show you how just yet. I'm just going to demonstrate. So if I do an ls-l on ncal in /bin, here it is. We see the owner, which is root, members of the group, which is also root, and everyone else has that X present. That means anyone can execute this. I'm going to change that. So I just did that. Now I do ls-l on ncal again. This program no longer has an X right there. It did just a moment ago. Now this means that only the owner, which is root, I'm not root, only members of the group, root, which I'm not a member of, can execute. Everyone else does not have that X there. No executable permissions on this file. So now if I try and run ncal, permission denied. I can't run that script. I cannot use that command anymore because it's not executable. So that X is very, very important. And you probably wouldn't go around removing those, but just to show you what the significance is. So to reiterate, if there's an X present for a directory, that means you can cd into it. But for a file, that means you can execute it. So I'm going to undo that. We're going to learn this command that I used to do it. It's called chmod, change mode. But now if I run that ls-l ncal, I have that X back. And now I can run ncal again. Okay. So now we're going to learn how to use this command to change those permissions. I just want to run through one more time what these three things mean. Well, there's 10 things, I guess. The first is a dash for a file, a D for a directory, an L for symlink. And then we have 3 groups of 3. Each of these groupings has 3 places. The first is either an R or a dash. An R means read permission is present. A dash means no read permission. W, write permission. A dash means no write permission. And then the final slot is for execute. X means it's executable. No X, a dash, means you don't have that permission. So the first 3, read, write, execute, are for the owner of the file or folder. The second 3 are for members of the group that owns that file or folder. And then the final 3 are for everyone else. So what does this mean? A little quiz here. What do this exact set of attributes mean? First of all, are we talking about a directory, file, symlink? Answer for your moment, or think about it for a moment. Answer out loud if you'd like. We are looking at a file. And we can see the owner, whoever that is, has full permissions, read, write, and execute. Members of the group owner have read, write, but no execute permissions, and everyone else only has read permissions. Okay, so now let's talk about how we actually change these. How do we use this weird chmod, however you want to pronounce it, command? It, first of all, stands for change mode. And it is the tool, it's the command we use to alter those permissions. And here's the basic syntax. There's actually two main ways of using chmod, of specifying the permissions. And the first I'm going to show you is the easier one when you're starting out. So we have the command chmod, change mode, and then the mode, meaning how we want to change the permissions. Who are we changing permissions for? What are we changing? Read, write, execute, and are we adding or removing that permission? And then finally, the file that we're trying to change. So this is where it gets a little tricky. The first thing we specify is the who. We have these different letters, U, G, O, and A. So U is how we can change the file permissions for the user, which is the owner of the group. It's a little confusing because O is actually for others. Anyway, if we have U, that means we're changing permissions for the user. G is for members of the group, O is for others, and A is for all of those. Then we have a minus sign, a plus sign, or an equal sign. So a minus sign will remove a permission, a plus sign will add a permission, we'll come back to equals. And then finally, the permission that we're trying to change, read, write, or execute. So let me just show an example to make it a little clearer here. If we have G plus W, what we're saying here is for members of the group, add, so plus, the right permission. So here's what it looked like before for group, R dash dash. After we run this, it's now R W dash. So we added that W there, but only for the group. Here's another example. Here, we have that right permission for owner and for group. We have an A, and that means all, so everyone, all three of these chunks, minus, remove the W, the right permission. So we go from having right here and a right here to now having no right permission, and no right permission. So let's show an example. Why don't I go back to my home directory as Colt, and let's see, I've got this permissions folder. Inside of it, I have only Colt can read.txt. Why don't I change it so that, how about everyone, so all of us can read the contents of this file. So it's not going to have a great name anymore. It will still be only Colt can read, but that's not going to be true. So this is what it looks like at the moment. I'm going to run chmod, change mode, and then I'm going to say everyone, so A, all. I want to add the read permission. So add the read permission for everyone. And then the file. ls-l. We now see everybody has an R. So this means if I go back to being Elvis, I can read the contents of that file now. Whoops, why don't I see it here? Oh, geez, because Elvis does not have permission to do anything in this directory. Remember, if we back out one level, here we are, this permissions directory, we can see there is no read attribute present, so Elvis can't even list the contents of that folder. So why don't we add that R back in with what we know? What I want to do is change mode, and I'm going to switch back to being Colt, change mode, and what I'm going to do is change it for other. So that's what the O, if I go back here, O means the world or others, anybody who's not the owner or part of the group. So here's permissions here. Everyone already has an R group, the actual owner, but I want to add this R back in. So I'm going to say for others plus R, add the read attributes for the permissions folder. Oh, I'm in the permissions folder. Oh, come on. I got to back out. Okay, let's try that again. For others, add the read permission to the permissions directory. Here it is right now. I'm going to hit enter, ls-l. And now what do we see on permissions? There is an R present. That means if I go back to being Elvis, I can now CD into permissions. And finally, I can read the contents of only Colt can read, because now we have permission to read both that file and the parent directory. Now I'll go back to being Colt. And what I'm going to do next is show, let's see how to revoke permission. So we use the minus sign. So I'll revoke, let's go back to, let's go back into permissions. here's that one file. I'm going to revoke the read permission for everyone except for me. So I'm going to do that here. So I'm going to do change mode. Why don't I revoke it for the group first just to show that? So I'm going to say group G minus R. For the group, members of the group, remove or revoke the read permission on only Colt can read. And now you'll see there's no R present here. I could do the same thing, but remove it for others. ls-l, we can see it's now gone. Now I can also do multiple at once. So if I did this, O minus RWX, this means others, remove, read, write, and execute permissions. So if I want to add, how about full permissions, read, write, and execute for everyone, I could do chmod, and then for everyone, all, I want to add read, write, execute on only Colt can read. And there we are, RWX, RWX, RWX. So it's now executable, it's showing up differently. It isn't actually going to do anything if I execute it because, well, it's not a script, it's just a text file. But anyway, that's kind of the basics. If I wanted to remove execute permissions for everyone, I could do chmod all minus X. And now we have RW dash, RW dash, RW dash. So that's a quick intro to using chmod with this syntax. Now, there's actually another syntax that we can use that is quite a bit more intimidating when you're starting out, and I'm just going to alert you to its existence. We can use octal notation, which is base 8, where these 3 digits of binary correspond to a file mode. So 000 is going to be dash dash dash. 111 is RWX. 100 is R dash dash. So that's the binary here. But each one of those in base 8 is a single digit, 0 through 7. It can be a little complicated to understand, but as you can see here, if you saw chmod 755, what that tells us is for that first chunk, 7 is 111, meaning RWX. 5 is 101, right? It's binary. 3 binary digits is a single octal digit. Anyway, R-X is what we end up with there. I know it's kind of confusing. It really is. Trust me, I have to teach this. But there are some modes that are more common, and you'll get used to them if you encounter them. But you can always use the longer sort of Englishy syntax that looks like this, with the letters and plus or minus, rather than having to worry about base 8 craziness. But that is something you'll see. Now, what about the equal sign? I said I'd come back to this. The equal sign is basically a way of saying, in this example, A equals R, set for all, set it to be only read permissions and nothing else. So it is going to reset every other value. So let's see an example of this in action. We just have this only Colt can read file, which is actually not accurate. But if I do want to make, let's say I want to, I don't know, we're grasping at straws here. I'll make it so everyone can read and only read. So no write permissions, no execute. What I can do is chmod, everybody, all. Now, instead of doing plus read or minus W, because minus W would subtract, right? So get rid of that, get rid of that. But if I do equals read, what this says is that the only permissions that we're having, ignore everything else and get rid of them, is read for everyone, for all. So ls-l, and there we go. Everyone can read, but nothing else. If I just did A equals, I can also do multiple, like RW or RWX, that's a long way, but I can give everybody permissions. And then if I went back and reran this so that it's equals R, again, that means only read, get rid of everything else. So we'll go from RWX, RWX, RWX to instead RRR and just dashes for the read and write permissions. All right, so I know this is a pretty complicated topic. There's a lot to chmod, not to mention just pronouncing it. Oh, I guess I did not show, we can also change permissions for multiple who's at one time. So if I wanted to add write permissions only for the owner and the group owner, I could do this, chmod So the owner is U, the group owner is G, and then plus W for right. And now we can see the owner and the group owner has that W there. So we can have multiple values on the left-hand side of that whatever plus, minus, equals. And then again, we have the octal notation, which you'll see, 777 means RWX for everyone, full permissions, and you can spend more time learning this if you really care about it. It is something you'll see in the wild, but for now, all I care about is that you understand the basic concept of these permissions and all these different letters here, RWX and dashes. What does that mean? What is the significance? And then remember, if we go back, we talked about the owner and how we can change a file's owner using chown. We can also use it to change the group that owns a file. And then we can change individual attributes using chmod, change mode. Whew, that was a lot. Well, we made it to the end. We covered a ton of different commands. Maybe it's a little bit overwhelming. Maybe you're a little tired of seeing all this scrolling text go by. But remember, the point of all this is not to memorize and just become an expert in every single command overnight. What really matters is being able to put the different pieces together to use the correct command when you need it, read the man pages, figure out how something works, change what options you're using, and just kind of duct tape it together when needed. Obviously, some of these commands become second nature, ls, cd, touch, make directory, rm, that sort of thing. You get pretty comfortable using different expansions and redirection and piping and combining different commands. But then some of these more niche commands, certainly I wouldn't expect you to just remember. And honestly, in preparing this sort of course, I always have to look at the man pages and remind myself of all the different options and how they work. So thanks again for joining me. And remember, if you are interested in my bootcamp, you can find the link in the description. And lastly, thanks again to Flavio for the excellent handbook. All right, well, it was nice, I guess, recording this in a dark room and editing it in an equally dark room, uploading it to YouTube, and being alone in this whole process. But honestly, who needs friends or companionship when you have the most sensual command? Man touch. That's really all I need. Okay, I gotta go get my cat to the vet.